And it actually is fairly common in most web design for there not to be additional space to move the grid around. And that's why I mentioned the justify items and align items properties, which move grid items inside grid cells when there's extra space inside the grid cells, is a lot more commonly used. In the final chapter, we'll look at how to control the placement and behavior of elements inside a grid with grid items. We'll be discussing placing grid items, spanning grid cells, and aligning grid items. So let's first talk about placing grid items. Grid items are automatically placed in a grid based on the order they appear in the HTML. Let's look at some example HTML, where we have 6 grid items inside a grid container. In the CSS file, in the grid container class, we've activated grid with display grid and given this grid 3 columns, each 1 fractional unit. In diagram form, we have our grid container, and our grid items are going to be positioned based on their order in the HTML, where the HTML order is going from top to bottom. So by default, our grid items are positioned like this. In the first row, we have grid item 1, grid item 2, and grid item 3, going from left to right. And in the second row, we have grid item 4, grid item 5, and grid item 6, going from left to right. So by default, grid items fill up from left to right, row by row. Now, grid items can be moved to different cells. Let's go add on our grid lines and see how this works. I'm going to be moving grid item 6. That is the grid item in the bottom right corner. We can use the grid row property, which is grid-row, and the value is 1/2. So what is this value? The 1 corresponds to the start line, and the number 2 corresponds to the end line. This is the start and end line of where grid item 6 will be positioned in relation to the row, because this is the grid row property. Importantly, grid row is set on the grid item, that is specifically on grid item 6. So by setting this, grid item 6 moves to this row. That's because this row starts at 1 and ends at 2. You can see those numbers on the left edge of the grid container. So what happens is that grid item 6 will now move here. And by default, it's always going to go to the first column. But it's now positioned in the grid row defined by the start line of 1 and the end line of 2. Now, because grid item 6 moves to the slot where number 1 was, it means our other grid items need to move. So grid item 1 now moves to where grid item 2 is, grid item 2 to where grid item 3 is, grid item 3 to where grid item 4 is, grid item 4 to grid item 5, and grid item 5 to where grid item 6 was. So other grid items move automatically when placing a grid item. So we've looked at the grid row property. Let's now look at the grid column property. It follows the same format, where 2/3 now represents the start line and end line of a column. So setting this property will result in grid item 6 moving to this column. That is where the vertical grid line is starting at 2 and ending at 3. So grid item 6 will move here, and this will result in grid item 1 moving back to position 1. So using grid row and grid column allows you to have precise control of where you want grid items to be placed if you want to override the placement of how they appear in the HTML. So let's go play around with this inside VS Code. Alright, so this is where we left off in the previous chapter. I'm going to go just simplify our grid container. There's a lot going on here we don't need. I'm just going to go remove all these properties and change our grid template columns to 200 pixels, just so that they're a bit bigger. I'll refresh, and we're now back to a simple grid, with our 8 grid items in 2 columns. The first thing I want to do is open up DevTools, so we can see our grid lines. So let's move grid item 6 to where grid item 2 is. To do that, I'm going to scroll down to grid item 6. Let's handle grid row first. The start line is 1, and the end line is 2. As we know, our horizontal grid lines are 1, 2, 3, 4, and 5, and you can see them down the left here. So we want grid item 6 for the row position, starting on grid line 1 and ending on grid line 2. So this will be 1/2. I'll refresh, and grid item 6 has now moved here. As I mentioned before, by default, if no grid column is defined, it will automatically go into the first column of that row. So let's now move it into this column here. We'll grab the grid column property, and we want it starting on grid line 2 and ending on grid line 3. You can see the numbers for our vertical grid lines, 1, 2, and 3. So to do this, we do 2/3. I'll refresh, and you'll now see that grid item 6 has moved from the position here to up here, and the other grid items have moved automatically. So let's now take a look at some placing grid items guidance. Placing grid items is used to achieve specific layouts. Looking at this example here, this kind of layout is common in a feature section, where we have alternating text and image in each row. Grid item 1 is the group text, grid item 2 is the image. This is in the first row. In the second row, the order swaps. So now the image is grid item 4, and the group text is grid item 3 in the second row. The reason this is the case is because in our HTML, it's best practice from a semantic perspective to have text followed by image. So in CSS Grid, we can use the technique of placing grid items to swap the order. For the third row, we would have grid item 5 for the text and grid item 6 for the image. Looking at this web page in mobile now, grid item 1 would be the text, grid item 2 is the image, grid item 3 is the text, and grid item 4 is the image. Now in the next topic, we're going to be learning about media queries and how we can achieve this. But what you'll see is that grid items need to change position on mobile. Now in actual fact, this positioning is just going to be achieved by just following the order of the HTML. But the grid items are changing position compared to what you see on desktop. And as I mentioned, we'll be discussing how to achieve this in great detail in the next topic. So let's now talk about spanning grid cells. Grid row and grid column can be used to have grid items span multiple rows or columns. Let's take a look at what I mean. Let's focus on grid item 1. We'll use the grid column property, where we're going to set the start line to 1 and the end line to 4. So you'll notice this time, the end line is not one increment above the start line, but several increments above. So what this results in is our grid item spanning multiple columns, like this. So grid item 1 is now spanning from the vertical grid line 1 all the way up until the end of the grid container, defined by grid line 4. Now because grid item 1 is now occupying the grid cell where grid item 2 and 3 are, our grid items need to move. So this is what happens. Grid item 2 is pushed down to where grid item 4 is. Grid item 3 is pushed down to where grid item 5 is. As a result of this, grid item 4 is pushed to where grid item 6 is. Grid item 5 goes on to another row, and grid item 6 also goes onto another row. So because of grid item 1 now spanning the entire row and entering into 2 grid cells, our grid items are moved to another row. Let's take a look at this same setup, but now focusing on the grid row property. Our start line is number 1, and you'll see now instead of an end line, I'm using the special notation of span with a number, where the number is the cells to span. So this is saying start at grid line 1 and span 2 grid cells. So the result will look like this. Our grid item 1 will span 2 grid cells. And just like before, because grid item 1 is now occupying another cell, our grid items need to shift around. Grid item 2 and 3 are fine where they are, but grid item 4 now needs to move to position 5, grid item 5 to position 6, and grid item 6 is going to be moved to another row. Now in reality, for most designs, you just simply wouldn't do this. You would ensure that the number of grid items is correct to achieve the layout you want. So you wouldn't be using 6 grid items here, you'd only be using 5. Let's go play around with this inside VS Code. Alright, so I'm back inside the file we were playing in earlier. I first just want to go remove the placement of grid item 6, just so we can restore everything back in order. So for this demonstration, I want grid item 5 to span 2 rows. So we'll go into grid item 5, we'll grab the grid row property, as we want to span 2 grid rows. I'm going to open up DevTools just so we can see our grid lines. So grid item 5, we want starting at grid line 3 over here and ending at grid line 5. So this will be 3/5. I'll refresh and you can see grid item 5 is now spanning these 2 rows. Grid item 6 is where it originally was. Grid item 7 has been pushed from over here to over here. And grid item 8 has been pushed onto a new row. Now this could also be achieved by typing span and the number 2. I'll refresh and you'll see there's no change. Now, as I touched on earlier, in your design, you wouldn't really have this happening with grid item 8 going onto its own row. In actual fact, you just wouldn't have a grid item 8. So I'm going to remove that. I'll refresh and you can see this is the layout we would achieve. So beforehand, you would know your desired outcome in terms of the design you're trying to achieve. And then when you're spanning your grid items, everything will fall into place nicely without grid items being pushed into new rows. So let's take a look at some spanning grid cells guidance. Grid cells can be spanned to create visually interesting designs. Looking at this example over here, we have our grid container. We have a grid item here, over here, and over here. I'm going to add in the grid lines. You can see the two grid items stacked on top of each other are spanning two columns, whereas the grid item on the right is spanning two rows. This kind of grid layout is actually fairly common on the homepage of a lot of tech companies. So let's now talk about aligning grid items. Grid cell alignment can be overridden for individual items. Now, this is not too common, so I wouldn't worry too much about it, but it is important you understand what it is. Let's say we have a grid container, and we apply justify item center and align item center. Inside our grid container, this would result in our grid items being centered inside the grid cells. So what I want to do now is focus on grid item 2, and we're now going to be applying properties to this specific grid item. The first property is justify self with the value of end, and what this does is aligns just grid item 2 along the row axis, overriding the justify item center applied onto the entire grid container. So focus your attention on grid item 2, and you'll see it moves to the end of the grid cell along the row axis. We can also apply the property align self, in this case with the value of start, and this aligns grid item 2 along the column axis, overriding the align item center value applied on the entire grid container. If you focus your attention on grid item 2, it will now move like this. It moves to the start inside the grid cell along the column axis. Now the values you can have for the justify self and align self properties include start, end, center, and stretch, where stretch is the default value. So let's go play around with this inside VS Code. Alright, so I'm back in the file we were working on earlier. For this demonstration, I'm just going to go add back in our grid item 8, and I'm going to go remove the grid row property on grid item 5. I'll refresh and we're back to where we started. Now for this demonstration, we need our grid cells to be larger than our grid items. Because our grid cells have a width of 200 pixels and the content number 1 is much smaller than the width of the grid cell, this will work fine horizontally. But for vertically, we need our grid cell to be higher, because the grid cell is just currently the height of the grid item. So to do this, I'm just going to go add some height onto the grid container, and let's make it 400 pixels. So you can see now, if I highlight number 1, there is height inside this grid cell. The background color red is just being stretched by default. So let's go position our grid items in the center of the grid cells. I'll grab the justify items property and set its value to center. I'll refresh, and you can see our grid items are now centered inside the grid cell along the row axis. Let's go center them as well vertically. We'll grab align items, set its value to center. I'll refresh, and you can see our grid items are now also centered vertically inside the grid cell along the column axis. So let's now go use the properties we learned earlier to only move grid item 3 into the top right corner of its grid cell. So for grid item 3, let's first position it along the row axis. We'll grab justify self and set its value to end. I'll refresh, and you can see grid item 3 has now moved to the end of the grid cell along the row axis. To move it to the top right, we'll grab the align self property and set its value to start. I'll refresh, and you can see grid item 3 has now moved to the start of the grid cell along the column axis. So the justify self and the align self properties are overriding the justify items and align items property set on the grid container. As I mentioned, I wouldn't worry too much about this as it's not too common to do, but you do need to know about it. So let's wrap up this chapter by building a new summary card, grid items. We first looked at placing grid items. Looking at grid item 3, we saw the grid row property places grid items along horizontal grid lines, where the number 1 is the start line, followed by a /, and the number 2 is the end line. The grid column property places grid items along vertical grid lines. So in this case, grid item 3 will stay in the first row, as that's defined by the horizontal grid lines 1 and 2, but it's going to shift its column defined by the vertical grid lines 2 and 3. So grid item 3 is going to move where grid item 2 is. As a result of this, grid item 2 will now move into position 3. We then looked at spanning grid cells. Focusing on grid item 2, we could use the grid column property to span grid item 2 across multiple columns. The number 2 is the start line, and the number 4 is the end line. It's the same notation as placing grid items, but for spanning grid cells, the end line will always be more than one increment above the start line. For this setup, grid item 2 will look like this, starting at the vertical grid line 2 and ending at the vertical grid line 4. Looking now at grid item 3, we can use the grid row property to span multiple rows. In this case, grid item 3 is going to start at the horizontal grid line 1, and we're using the notation here, span with a number, which defines the number of cells to span, in this case 2. So this will result in grid item 3 now spanning 2 columns where it starts at the horizontal grid line 1. The last concept we looked at was aligning grid items, where we saw we could override the alignment of specific grid items. In this case, our grid container has justify items and align items set to center. On grid item 5, we can set the justify self property to end, which will position grid item 5 along the row axis. And in this case, the value is end. So it's going to move grid item 5 to the end of the grid cell along the row axis. We can use the align self property to position the grid item along the column axis. In this case, grid item 5 will be positioned at the start of the grid cell along the column axis. Okay, so let's go use placing grid items to finish off the feature section on our Quill homepage. We have our grid container, our grid items, and in the middle row, we want to place our image where the grouped text is. So I'm back inside the app.css file for our Quill homepage. I'll scroll down to the grid, and we need to move this image over here and this text over here. Now to do this, I'm going to head to the HTML file, and for the middle row, on this image, I'm going to go add a class, so that we can select it and move it. That's this image over here. It currently has a class already, feature-image. We're going to go define a new class, which is feature img swap order. I'll just copy this. I'll head back to app.css. I'll select this class. I'm going to zoom out a bit and open up DevTools so we can see our grid lines. So we want our image over here, which we've just given a new class, to remain in the current grid row, which has a start line of 2 and an end line of 3. And move to this column over here, which has a start line of 1 and an end line of 2. So let's go do the row first. We'll grab the grid row property. It has a start line of 2 and an end line of 3. For the grid column, it has a start line of 1 and an end line of 2. I'll refresh, and you'll see now we've moved this image over here, and as a result, the text is pushed onto the right, with the other grid items unaffected. Now, just to highlight, even though the image remained in the same row, that is defined by the start line 2 and the end line 3, if I didn't define that, it by default will move up to the top row. Alright, so let's take a look at our page in all its glory. Our hero section is looking great. Our feature section is now looking beautiful with the use of CSS Grid. And our call to action section is also looking superb. Now in the next chapter, we're going to be learning about media queries, which is all about responsive design for different screen sizes. Now, there are just 1 or 2 things that are annoying me about this page that I want to fine tune. For some reason, this is still black. So we're going to go make that white. And the other thing annoying me is that these anchor tags down here are not styled for different states. In the pseudo class section of the course, we focused on states for buttons. And I kind of said these weren't that important to do, but they are annoying me now. So let's go fix those up. All right. So in our app.css file, our heading over here is defined by the CTA heading. In the HTML file, you can see in the CTA section, we have CTA heading. So let's simply go add the color property. We have the white color stored in a variable with the name white. I'll refresh, and the get started now text is now white. For these anchor tags down here, we're going to scroll up to our global styles. And at the moment, this is how we're defining our anchor tags. But let's now go add pseudo classes onto these anchor tags for different states. As a reminder, for our buttons, we group together the link and visited states, and hover and active states. So let's go first do the anchor tag link pseudo class and anchor tag visited pseudo class. For these, I just simply want to apply our base text color. Scrolling up, this is simply our gray base. I'll copy this and I'll paste it over here. I'll refresh, and you can see our anchor tags now look a lot more in line with our design. Now, in actual fact, I don't really care about different colors for the hover and active state. So in fact, I'm just going to group these all together, hover and active, and I'll refresh, and this will just ensure that for any state, our anchor tags remain this color. All right, the final thing I've noticed is that this heart over here should be purple. So let's quickly go do that. In index.html, I'm going to scroll down to our footer. As this is a text element we want to style, we're going to go add some span tags. I'll copy the heart, place it in the spans. I'm going to give our spans a class of heart icon. I'll copy this text. In app.css, I'm going to scroll down to our footer. Below the social icons, I'll select this class, and I want to give it our secondary color. We store this in a variable, which is secondary base. I'll refresh, and we now have our beautiful purple heart. All right, so our homepage is basically done. In the next chapter, as I mentioned, we're going to learn about responsive design so that our page can adapt to different screen sizes, because at the moment, it's only designed for desktop. Great work. CSS Grid is now complete. With both Flexbox and CSS Grid in your toolkit, you've taken a major step toward mastering modern web layouts in CSS. It's now time to learn about responsive design. Responsive design ensures that websites look great on all screen sizes, from mobile devices and tablets to large desktops. In this topic, we'll explore how to use media queries along with relative units and fluid layouts to create flexible, adaptive designs that adjust seamlessly across different screen sizes. Let's begin by learning how to make websites responsive across different screen sizes with an introduction to responsive design. We'll be discussing responsive design, media queries, relative units, and fluid layouts. So what is responsive design all about? Web pages were originally designed only for desktop computers, as they were the only device available to access the internet. As I'm sure you know, a desktop computer is a fairly hefty machine that sits on your desk. Now today, there are a variety of devices with different screen sizes, so web pages need to adapt for a more functional user experience. Looking at the range of different devices we have our desktops, we have laptops, which are smaller and more portable computers, we have tablets, and we also have smart mobile devices. Now, for a good user experience, a web page appears different between different devices. Let's take a look at an example of this. Okay, so I've opened up DevTools, and I've clicked the toggle device icon here. This allows me to change the width of the browser so we can see what happens. At the moment, I'm at 2000 pixels wide. This would be a very large desktop computer. Let's come and reduce the width a bit and see how the elements and layout changes. You can see at this point, the layout completely changes. The image, which was on the right, has now moved below. Let's continue to reduce the width. You can now see the layout again changes, with the buttons going the full width of the screen and the font size reducing. Some spacing properties like margin and padding would also have reduced. Let's continue. So as you can see from this, as we reduce the width of the browser to simulate the web page at different screen sizes, the web page totally changes, both in layout, that is, where elements are placed on the page, as well as the size of properties, like font size, and different spacing properties like padding and margin. Now, responsive design is powered by three main pillars. The first pillar is relative units, like percentages and rems, which we've covered at length in the course already, and we'll be discussing more soon. The next pillar is fluid layouts. This is Flexbox and CSS Grid, which we've also already covered at length. And the third pillar we need to learn about now is media queries. So what are media queries? Media queries apply styles to a web page based on specific conditions. In CSS, it looks like this. We declare an @media, which is a special rule called the @rule. We then have some regular brackets, where inside we set a condition. In this case, a max width of 500 pixels. And then just like regular CSS rules, we have our curly brackets, and inside these, we apply specific styles, like an H2 with a font size of 14 pixels. So what this is essentially saying is that when the page is less than 500 pixels, apply these rules. So let's go look at this a bit more in diagram format. I'm going to set up an axis here with different browser width values. We're going to start with 0 pixels. The next value will be 500 pixels. The next value 1000 pixels. And the last value 1500 pixels. So let's go and apply different media queries for an H2 heading. We'll start when the browser is less than 1500 pixels. That is this range over here. We would define our media query like this: @media with a max width of 1500 pixels. And inside that media query, we're setting the H2 to have a font size of 24 pixels, which would look something like this. Let's now go add a media query for pages less than 1000 pixels. That is this range over here. That would look like this: @media with a max width of 1000 pixels, where our H2 is now a different font size of 18 pixels, which would look something like this. And finally, let's go change our H2 for browser widths or screen sizes less than 500 pixels. That is this range over here. And that would look like this. At media, with a max width of 500 pixels. And inside there, we have our H2 with a font size of 14 pixels, which would look something like this. So you can see at different screen sizes, our H2 font size will be different. Now, some global styles like colors and fonts are applied no matter what the screen size is. So these are actually defined outside media queries, and we'll be looking at this inside VS Code soon. For example, let's say the H2 has a font family of Poppins. It's very rare we actually want to change that for different screen sizes. So that kind of property is a global style which isn't set inside a media query. Now, the important thing we need to get our head around is that the order that these media queries appear in our CSS is really important. For example, let's look at a browser width or screen size which has a width of 300 pixels. Now, if you think about it, in fact, all of these media queries are applying. For the max width of 1500 pixels, this applies when the screen size is less than 1500 pixels, and 300 pixels is less than this. So this is applying a font size of 24 pixels. For the media query max width 1000 pixels, this applies when our browser width or screen size is less than 1000 pixels, and 300 pixels is less than this. So the font size of 18 pixels is also applying. The last media query, with a max width of 500 pixels, will apply the H2 style when the browser or screen size is less than 500 pixels, and 300 pixels is less than 500 pixels. So the font size of 14 pixels is also being applied here. So how does this actually work? So if all the media queries are applying, how do we ensure that for a screen size of 300 pixels, only the top one, which sets a font size of 14 pixels, is applying? To solve this, we use the CSS cascade. We would have the largest max width value first, like this, and then we would go down in descending order. So after this would be the max width of 1000 pixels, and after this, a max width of 500 pixels. So effectively, our media queries are going in descending order of their max width value, which means that the smallest screen is always last. And as we know from the CSS cascade, when we have conflicting styles, later rules will always win. So in our example, with a browser width or screen size of 300 pixels, all the different H2 font size values are trying to be applied because the condition is met, but it's only the last one that is actually applied because that appears last in the CSS. So I just wanted to get across the order that we put our media queries in our CSS file is incredibly important. So let's go play around with this inside VS Code. All right, so I've gone ahead and set up an index.html file, and I've linked a style sheet which is currently empty. I'm going to come inside the body and just add an H1 with the text media queries. Inside app.css, I'm going to select this H1. I'm going to give it a color of red, a font size of 80 pixels, and let's go change the font family to Georgia here. So let's check this out in the browser. All right, so I'm going to open up DevTools. I'm going to come to the toggle icon here, and this will allow us to change the width of the browser. Now, as you'll expect, as I change the width, nothing is happening. But let's go add some media queries now so that the styles will change as we change the width of the browser. We'll get our @ rule of @media. We then grab regular brackets, and I'm going to go use the values we used before. I'm going to get a max width and set its value to 1500 pixels. Then grab our curly brackets like usual, and inside here, we now add different CSS rules. I'm going to select the H1, I'm going to give it a color of blue, and I'm going to change the font size to 60 pixels. So what this is saying is that between 0 and 1500 pixels, apply these styles. At the moment, I'll save and refresh. I'm just going to extend the browser a bit further. You can see I'm currently at 1559 pixels, which means this max width is not yet taking effect. So these global styles are being applied. When I come and reduce the width of the browser to less than 1500 pixels, you'll see the H1 changes to a color of blue and a font size of 60 pixels. So these styles have now been overridden. And because I'm not changing the font family value, because we would consider this a global style, which lives outside the media query, that doesn't change. Let's now go add another media query. I'll grab @media, we'll get max width, and set its value to 1000 pixels. We'll grab our curly brackets, and again, we'll select the H1, and let's now change it to have a color of green and a font size of 40 pixels. Okay, I'll refresh. So because our width is 1041 pixels, this rule is being applying. But now watch what happens as I reduce the browser to less than 1000 pixels. I'm now at 900 pixels, and you can see the H2 is now green with a font size of 40 pixels. And as I mentioned earlier, the order you put the media queries in is really important. because both of these are trying to be applied. Because 900 pixels is less than 1500 pixels and less than 1000 pixels, both these CSS rules are attempting to be applied, but only this one applies, which is what we want, because it appears last in the CSS file. When I select the H1 in DevTools, you can see the media queries coming into play. The max width of 1000 pixels is being applied, and you can see over here, this media query is also attempting to be applied, but it's being crossed out because it appears before this media query here in our CSS. I also want you to note that the original styles of color and font size are also being striked out because they appear before our media query rule here, but the font family is still being applied, which is a global style we don't want to change as the width of the browser reduces. Okay, let's go add our last media query. We'll grab @media, we'll set a max width of 500 pixels, we'll grab the H1, we'll set the color now to orange, and we'll change the font size to 20 pixels. I'll refresh, and let's now go reduce the width of the browser. You'll see as I hit 500 pixels and below, the H1 now changes to orange with a font size of 20 pixels. So let's go and play with all the different values we have now. I'm going to extend the browser to a value bigger than 1500 pixels. You'll see it starts red. As I reduce, it changes to blue with a smaller font size. It then changes to green with a smaller font size, and then finally changes to orange with an even smaller font size. All right, so what I want to do now is set up a small project we're going to be working on in this chapter. It's going to allow me to demonstrate the 3 different pillars of responsive design I touched on earlier. That is relative units, fluid layouts, and media queries. So I prepared the HTML ahead of time. I have a main div with the class reviews grid, and this contains 4 grid items. Over here, over here, over here, and over here. The grid items are the same structure, just with different content. Each review card contains an H3 with the class review heading and some review text like review 1, a paragraph with the class review text with some review content, and then finally another paragraph with the class review person with the name of the person who gave the review. As I mentioned, this structure is repeated for all 4 grid items, and only the content changes between them. So let's open app.css and push it on the right here. So what we're going to go do is make a 2x2 grid, which would form the review section of a web page. Let's first grab our universal selector to do a CSS reset. I'm going to strip the padding away by giving it a value of 0, and strip the margin away by giving it a value of 0. Let's also go change our box sizing value to border box. Okay, next up, let's go grab the body tag. Let's go give it a font family of Arial, and I'm going to give the entire body a background color of light gray. So let's now go make our grid. The grid container is being defined by this class here. So let's go select reviews grid. To activate CSS grid, we change the display property to grid. Because we want our grid to be 2x2, we're going to go grab grid template columns and give it the value 1FR, 1FR, which defines our 2 columns, which will take up equal width of the available space. Let's give the entire grid review a max width of 1200 pixels. All right, let's check this out in the browser so far. All right, so nothing special, but we have nicely set up our grid structure. I'm going to go add some column and row gap to better separate these out. So I'll add a gap property with a value of 20 pixels. Now at the moment, our grid is stretching the full width of the screen and sits right at the top over here. So let's just go give it some margin. I'm going to give it 100 pixels top and bottom and give it the value auto for left and right. So this has now moved our grid 100 pixels down, and there's also some margin 100 pixels below. And if I open up DevTools and go to a width beyond 1200 pixels, like this value here, you can see our grid has nicely been centered. Where we know from previous chapters, the auto value applied left and right will calculate available space and divide it equally left and right. All right, so let's now go add some styles to our review card. In our HTML, that's this div over here. So I'll select review card. We'll give it a background color of white. I'm going to add padding all around the card of 20 pixels. Let's give it a border of 1 pixel solid and dark gray, and a border radius of 8 pixels. All right, I'll refresh, and you can see now our cards look a lot more like cards. Let's now go and apply some styles to the different text elements inside our card. We have review heading, review text, and review person. Let's start with review heading. I'll select that. We'll give it a font size of 40 pixels and a font weight of 700. I'll refresh, and you can see the review text goes a lot larger. Let's now go handle the review text here. That was the class review-text. We'll just give it a font size of 20 pixels. I'll refresh. And the final style is review person. Let's give it a font size of 18 pixels. And we'll change the font weight to 700. Okay, let's refresh. All right, the last thing I want to do is just create a bit more space inside these cards. So review heading, I'm just going to go grab the margin bottom property and set its value to 20 pixels. And on the review text, let's go grab margin bottom and set the value to 10 pixels. All right, so we've set up our review grid. Now, as I reduce the width of the browser, you'll see this viewing experience doesn't look great as the browser reduces. First of all, the content is butting up all the way left and right. The font size and all the elements is just too large for smaller screen sizes. And some of the spacing values, like the padding and margin, also makes it look a bit awkward. And finally, this grid layout is just not working anymore. It would be much better to now break the grid layout so that each review just stacked on top of each other. So let's now go use media queries to improve this for different screen sizes. The first media query, we'll grab our @media, open up our brackets. I'm first going to do different styles for a max width of 1000 pixels. So the rules I define here are going to apply when the browser is less than 1000 pixels. Let's first select our review card. The current padding there is 20 pixels. Let's go reduce that to 15 pixels. And then going to grab the review heading. Currently, the font size there is 40 pixels and the margin bottom is 20 pixels. Let's change the font size to be 30 pixels and the margin bottom to be 15 pixels. For the review text, the font size is 20 pixels and the margin bottom is 10 pixels. So let's go reduce those values. We'll change the font size to 16 pixels and the margin bottom to 8 pixels. Finally, for the review person, its font size is 18 pixels. So let's go reduce that. We'll change its font size to 14 pixels. Okay, so let's check this out in the browser. I'll refresh. I'm now going to reduce the browser to a width less than 1000 pixels. And you can see how everything updated. This now looks a lot more appropriate for this screen size. So just to show you again, this is how we started. As the screen size reduces, the review card padding reduced, and the font size and margin bottom values also reduced. However, as I keep going smaller, you can see this also doesn't look great. We want to continue to reduce some of these values. So let's go add another media query. Just to make this simple, I'm going to copy this one and paste it below. I'm just going to change the max width value to now 500 pixels. So these rules will apply when the browser is less than 500 pixels. Let's go change our review card padding to 10 pixels, our review heading font size to 20 pixels, the margin bottom to 10 pixels, the review text to a font size of 14 pixels, and a margin bottom of 5 pixels, and the review person to have a font size of 12 pixels. All right, I'll refresh and watch what happens as the browser reduces below 500 pixels. All the font size and spacing values like padding and margin adjust. So let's go through the whole spectrum. We start here, hit a value less than 1000 pixels, continue down, and then again hit a value less than 500 pixels. And you can see that for each of these screen widths, the reviews grid is now better designed. So you can see how we've effectively used media queries for different screen sizes. Now, the only problem with this approach is that for every single property, we had to manually go change its size. And this is just a bit of a painful exercise. And that's why relative units is one of the other pillars of responsive design, where relative units avoid us having to define these for every single property. So let's now look at relative units in more detail. Relative units ensure elements scale proportionally based on parent container size or scalable reference points. Parent container size is all about percentages, and scalable reference points is all about rems. Let's look at an example of using these. The web page on the left is in desktop view, and on the right in mobile view. Percentages is used on a main page container to ensure that when the container scales down on a mobile device, there is still space left and right, so the content isn't butting up right against the screen. Percentages are also used on elements like images, so that on smaller screens they scale down. Rems are very commonly used for spacing, like margin and padding. On the web page on the left, there's margin between the navigation bar and the main heading, and this margin value would be reduced on a mobile device. Rems is also very commonly used on text. So this heading over here would use a larger rem value compared to the rem value on a mobile device. All right, so I'm back inside the project we were working on earlier. Inside our HTML, I want to go define a main container to contain all the content. I'll grab a new set of divs, I'll cut all this content and paste it inside the div. I'm going to give the div a class of main container. Inside the CSS, below the body tag, I'm going to add our main container class. I'm first going to center the main container by setting the margin value to 0 top and bottom and auto left and right. It's then common to define a max width so that our content doesn't stretch too wide on large screens. I'm going to give it a max width of 1200 pixels. And then I'm also going to go add a width and give it a value of 90%. And this will ensure that on browser windows less than 1200 pixels, the width of the content is only 90%, which will ensure that there's space left and right so the content doesn't butt up right against the edge. I don't want to refresh just yet, so I can show you how when I reduce the width of the browser, the content is going right up to the edges. I'll refresh now, and you can see now our content doesn't go all the way to the edges and is an improved viewing experience. Okay, so you can see our percentages is very helpful for responsive design on an element like a main page container. All right, we're now going to be shifting it up a gear and talking about REMs in the context of media queries, as there's a few funny things we need to get our head around. The first thing I want to discuss is REMs inside media query conditions. The REM value inside a media query condition is always based on the default browser font size. Now, I want to be very clear here. I'm specifically talking about the media query condition. That is, the max width value we're setting inside the brackets. And we know that from previous chapters, the default browser font size is 16 pixels. All right, so this seems very confusing. So let's go through it step by step. Let's say we had a CSS file with the rules defined here. We know that it's very common to set the root HTML font size to 62.5%. That's because 62.5% times 16 pixels, which is the default browser font size, is 10 pixels. And we do this because 10 pixels is a much easier unit to work with compared to 16 pixels. Because the default browser font size is 16 pixels, that means that by default, one rem is 16 pixels. But by adding this line of code, we've now changed it so that one rem is 10 pixels. And this makes using rems inside our CSS a lot simpler, where 4 rems would be 40 pixels and 2 rems is 20 pixels. Now let's move over to our media query condition. You can see inside the brackets, I currently have set a max width of 31.25 rem. Now, the important thing that we need to understand is that the rem value inside this condition, that is over here, is still based on the default browser font size. That is, 1 rem equals 16 pixels. So even though we've adjusted the rem value in our CSS on the left by changing its font size to 62.5%, that is 10 pixels, this doesn't carry through into the rem value used in the media query condition. That's still based on the default browser font size. So effectively, this media query has a max width of 31.25 rems, which would be 31.25 times 16 pixels, which is 500 pixels. So it's really important to realize that the rem values inside the conditions is based on 16 pixels and not what you define when setting up the font size on your root HTML. All right, so I'm back inside our project. Below the universal selector, let's select the root HTML element and let's change its font size to 62.5%. This effectively adjusts the default font size in the browser of 16 pixels to 10 pixels. That is 16 pixels times 62.5% equals 10 pixels. And we know that this is much better practice compared to just changing it to 10 pixels like this, because this overrides the different font sizes in the browser. And let's go change the condition to use rems instead of pixels. Now, even though we've adjusted our rem value to be based on 10 pixels, as we've just discussed at length, this value is still based on the default 16 pixel font size value. So to change this to 1000 pixels, we need to calculate 1000 pixels divided by 16 pixels, which gives us 62.5. So we need to now adjust this max width value to 62.5 rem. Just to check this works, I'll refresh and let's go scale our browser down to 1000 pixels, and you'll see that the styles inside this media query are being applied. Now, just to highlight why this could be confusing, is that because in our HTML root element, we've set our font size to 62.5%, which is effectively 10 pixels. So you may have thought that the 1000 pixels we had here before, if we wanted to change this to rem values, it would be 1000 pixels divided by 10 pixels, which is the value currently sitting on our root HTML element. So this would then be 100, which means that you would come and change this to 100 rem. But the rem value inside this condition is 16 pixels, even after adjusting the font size of the root HTML element here. So this is not actually 1000 pixels, it's 100 times 16, which would be 1600 pixels. So long story short, it's just really important to realize that the rem value specifically inside the media query condition is still based on the default font size value of 16 pixels. So we'll leave that as 62.5 rem. Let's go adjust the other max width value here to rems. So to work out the rem value, we do 500 pixels divided by the default browser font size of 16 pixels, which gives us a value of 31.25. Let's go change this to 31.25 rem. And just to check it works, let's go down to 500 pixels, and you'll see that when we hit that value, all these styles now apply. Now there's a few reasons why we want to use rem values inside our max width condition, as opposed to pixels. One of the reasons is that we're going to be using rem values throughout the project for our other units, so this keeps things more consistent. And it also ensures if someone ever did go adjust the font size in their browser, everything would still be consistent. So it's just better practice to use rem values inside your media query conditions as opposed to pixels. So now that we've spoken about rem values inside the media query condition, let's now go talk more about how we use rem values inside the media query itself. So we'll now be looking at detail in how we use rems inside media queries. Rem values scale proportionally, adjusting both existing and new values based on the updated root font size. So let's take a look at what I mean here. Let's say we have this CSS file. We've changed the root HTML font size to be 62.5%. That is 62.5% multiplied by 16 pixels, the default browser font size, gives us a font size of 10 pixels. This now means 1 rem is equal to 10 pixels, which is a much easier unit to work with when sizing CSS properties compared to 16 pixels. Let's now look inside our media query. We've defined a max width of 62.5 rem, and as we've just discussed, the rem value inside the condition is based on the default browser font size, which is 16 pixels. So this max width would kick in at 62.5 multiplied by 16 pixels, which would be 1000 pixels. Inside the media query, you can see we've changed the HTML font size to 50 pixels. What this now means is that for screens less than 1000 pixels, the root HTML font size is 50% times by the default browser font size of 16 pixels, which is 8 pixels, which means that 1 rem is now 8 pixels. So our rem value has now been reduced from 10 pixels to 8 pixels. That is, it has been reduced by 8 pixels divided by 10 pixels, which is 80% of the original size. So let's first look at how this affects existing properties using rems. When I say existing properties, I mean properties already defined in our CSS. In this case, the H1, which has a font size of 10 rem and a padding of 5 rem. All properties using rems will automatically shrink to 80% of their original size. So the font size was originally 10 rems and had a padding of 5 rems, which means the font size is 100 pixels, 10 times 10 pixels, and the padding is 50 pixels, 5 times 50 pixels. But now inside our media query, when the screen is less than 1000 pixels, our H1, which is defined outside the media query, now shrinks by 80%. That is, the font size will now shrink from 100 pixels to 80 pixels, and the padding will shrink from 50 pixels to 40 pixels. And this is all being controlled by changing the root HTML font size inside the media query. Let's go play around with this inside VS Code. All right, so I'm back inside our project, and we're now going to go use rems to write more efficient CSS. So initially what we're going to be doing is just updating a lot of our pixel values to rem values. And then we'll see inside media queries how we can adjust the font size of the root HTML element to write more efficient CSS. Now, usually with max width values, we do leave those in pixels. So I'm not going to touch those. For the gap property, I am going to come and change this to rems. Now, once again, the font size on our HTML root element is 62.5%, which means that 1 rem equals 10 pixels. So let's change 20 pixels to 2 rem. For the margin, we'll change 100 pixels to 10 rem. On the review card, we'll change 20 pixels here to 2 rem. For border, we do usually use pixels. And for border radius, we also use pixels. So I won't change those. On the review heading, the font size will change to 4 rem. And margin bottom will change to 2 rem. For the review text, we'll change this to 2 rem. And the margin bottom to 1 rem. And finally, for the review person, we'll change this to 1.8 rem. Okay, I'll refresh and you'll see there's no change. And that's just because I've just updated our values to use rems instead of pixels. But now let's see the magic of rem units. As I mentioned earlier, inside this media query, I'm having to explicitly change every single property that uses pixels. I'm having to reduce the pixel value of every single property. Now, this is a small project, but you could imagine for a homepage with many more sections and components, this would be very painful to do because there could be hundreds of these. So instead of doing that, we just come and change the font size of the root HTML element. Currently, it's sitting at 62.5%, which is 10 pixels. So let's now reduce this. I'll grab the HTML element. We'll change its font size to 50 pixels. That is the default font size of 16 pixels times by 50%, which equals 8 pixels. So by writing just this one line of code, anything that uses a rem value, like the font size here, the margin bottom here, is now being reduced. So it's no longer based on 10 pixels, but based on 8 pixels. So for example, the review heading, which has a font size of 4 rems, outside the media query would be 4 times 10 pixels, so 40 pixels. But now, inside the media query, the rem unit is 8 pixels. So this would be 4 times 8, which is 32 pixels. So every single one of these units has now scaled down. Let's refresh and check this out. I'll reduce the width of the browser to a value less than 1000 pixels. And you can see how everything nicely scales. And this has been achieved by one single line of code. Let's go do the same thing in this media query. I'm going to remove all these styles. We'll grab the HTML root element and let's set its font size to 37.5%. That is 16 pixels times by 37.5%, which is 6 pixels. So now all the properties using rems are now based on 6 pixels. So this font size was initially 40 pixels. When it's less than 1000 pixels, from the media query here, when it's less than 1000 pixels, it reduced to 32 pixels, which is 4 times 8. And now when our browser is less than 500 pixels, our rem value is 6 pixels, which means that the review heading font size will now be 4 times 6, which is 24 pixels. So let's refresh, and I'm going to reduce the browser below 500 pixels. And you'll see once again how all our elements scale based on a single line of code here. Now let's go see these properties changing inside DevTools. We'll look at the feature heading to start. You can see on the computed tab, you can see its font size is 40 pixels, where one rem is 10 pixels. So 4 times 10 is 40 pixels. When I reduce the browser below 1000 pixels, you'll see its font size is now 32 pixels. And that's because at this width, one rem is equal to 8 pixels, where 4 times 8 is 32. Let's scroll now below 500 pixels, and you'll see now the font size is 24 pixels. That's this media query coming into action, where one rem is 6 pixels. So 4 times 6 is 24. And this exact same thing is happening for anywhere we're using rems. As another example, let's look at the padding on our card. You can see the padding is currently 20 pixels. Let's go below 1000 pixels. You'll see the padding is now 16 pixels. And if I reduce it below 500 pixels, the padding is 12 pixels. So that's how rems works. So by reducing the font size on the HTML root element, all properties using rems will effectively shrink as we reduce the width of the browser. So that's all about existing properties. So let's now talk about using new properties inside a media query. So we'll now be taking a look at new properties inside media queries. New properties added with rem will be based on the new pixel value, not 10 pixels. So let's see what I mean by this. I'm going to update our media query to now style an anchor tag. You can see it has a padding of 2 rems, top and bottom, and 4 rems left and right. This styling of our anchor tag was not present in our CSS file. It's being added for the first time inside the media query. So now stop and think about this. The value 2 rem is not 2 times 10 pixels, because in our media query, 1 rem is 8 pixels, which means that the top and bottom padding is 16 pixels. That is 2 times 8 pixels. And the padding left and right is 4 times 8 pixels. That is 32 pixels. So this is just a bit painful. It means that for every media query, when you want to come and add a new property, technically the rem value will be different depending on what media query you're in. And you can imagine that having to do the mental math where your rem value is changing inside each media query is just a bit painful. Because A, you need to remember which media query you're in and what the rem value is there. and B, you're no longer working with a nice rem value of 10 pixels. Now the good news is you don't actually need to worry about this. And that's because when adding new rem values inside a media query, select values you would use for the base case and it will scale automatically. Looking at our CSS and media query so far, for the 2 rem and 4 rem value that we're adding on the anchor tag, you just need to think as if 1 rem is 10 pixels. And that's because inside the media query, the padding on the anchor tag will automatically scale down. So when adding new properties in your media query, don't worry about exact pixel values for each media query. Focus on what you would do on the base case. And when I say base case, I mean the 10 pixels base case. Because whatever you would do for the base case, when 1 rem is 10 pixels, this will automatically adjust and scale down inside the media query. So definitely don't sit there and whip out a calculator and think about the new rem value for each media query. Just continue to use 1 rem as 10 pixels in your head and pretend like you're designing it for the base case. And then inside your media query, it will automatically scale down. Let's go play around with this inside VS Code. Okay, so I'm back inside our project. Now adjusting the root HTML element font size like this is a fantastic way to instantly scale all properties using rems. The only problem with it is that sometimes you want to do a bit more fine tuning. So for example, at this screen width of less than 1000 pixels, I think that this card could do with some more padding. At the moment, the padding is 2 rems. So inside this media query, the padding would be 2 rems times by 8 pixels, which is 1 rem inside this media query, which is 16 pixels. So what I'd like to do is actually increase this for this media query. So I'm going to grab the review card class, and I'm going to set the padding to 3 rem. Now I know I spoke earlier about this process for adding new properties that didn't exist in the CSS beforehand, and padding is an existing property. But the process of fine-tuning existing elements is the same thing, because we are effectively targeting an element and overriding what the HTML root element font size is applying to the padding. So just keep in mind this process is done for both applying new properties in the media query, but also for pinpointing existing properties and fine-tuning them. Now, with this padding value of 3 rem, I'm not thinking about this as 3 times 8 pixels, which would be 24 pixels. All I'm doing is keeping my mental model of 10 pixels, so this would be 30 pixels, and I know that because I'm inside this media query, where I've reduced the font size of the HTML element, it will scale down. So I'll refresh this, and for me, this padding just looks a bit better. And in all honesty, this is just a bit of an iterative process, and I really wouldn't overthink it. You just need to come and play with different rem values here until you're happy. I could have changed this to 4 rem, which would give it even more padding. But I do just want to stress that this rem value is now actually being calculated where 1 rem is now 8 pixels. And you can see that in the box model. If I select the card and scroll down to the box model, you can see its padding is 32 pixels, which is 4 times 8 pixels. Now, long story short, I really wouldn't overstress this, and I wouldn't be adding or refining elements and having to think about the new rem value inside each media query. Just continue to work on your 10 pixel base case, see how that looks, and then just come and change it up or down as you please. But this process is fairly common, where initially we change the font size of the root HTML element to dynamically adjust all our properties. We then look at our design and see anything that needs fine tuning. And for me, it was the padding. And once again, just understand in the back of your mind that this rem value is now based on 8 pixels, but in reality, just continue to think of it as 10 pixels, and it will automatically adjust, and just go through a bit of an iterative process inside the browser to land on a value that you're happy with. Alright, so we've looked at media queries, we've looked at relative units, percentages and rems, and now it's time to discuss the third pillar of responsive design, which are fluid layouts. Using Flexbox and CSS Grid allow layouts to dynamically adjust in size and position easily. Looking at the desktop view of this web page on the left, and the mobile view on the right, you can see the layout is initially a 2x4 grid, but then on mobile, it changes to a 4x2 grid. Now the good news is this is really easy to do inside our media queries. So I'm back inside our project, and what I'd like to do is that when we get to a browser width less than 500 pixels, I want our reviews to no longer be in a grid, but just stack one on top of each other. At the moment, our grid is being defined here, where we're currently defining 2 columns, each 1 fractional unit. So now all I need to do is select this class inside our smallest media query, and just update the grid template columns to 1FR. This is now defining a grid with one column. And watch what happens as I go below 500 pixels. Our grid items automatically shift into a 4x1 grid. And there you can see the power of fluid layouts like CSS Grid inside media queries. Alright, let's finish up this chapter by starting the next summary card, responsive design. In this chapter, we focused on media queries, which apply styles based on different screen sizes. The media query looks like this, where it starts with @media, and inside the brackets, we define a condition. I highlighted that the rem value used inside the media query condition is always based on the default browser font size of 16 pixels. So even if you adjust the HTML root font size in your CSS to say 62.5% or 10 pixels, this isn't the rem value used inside the condition. It's always based on the default browser font size of 16 pixels. We discussed how existing properties using rem values will adjust when changing the root HTML font size inside the media query. Over here, the properties adjust because by changing the root HTML font size to 50%, it now becomes 16 pixels, the default browser font size, times by 50%, which equals 8 pixels, which means that inside our media query, one rem is now 8 pixels. So any properties using rem values now reduce to 8 pixels, where outside the media query, they're likely based on 10 pixels. And we saw that by changing the root element font size with one line of code, we can dynamically adjust all properties using rems. We also discussed how new properties are based on the new pixel value. And this also applied to adjusting existing properties. So in this example, we're adjusting the padding of our anchor tag to be 2 rems top and bottom and 4 rems left and right. But the 2 rems is now based on 8 pixels. So 2 times 8 is 16 pixels. The 4 rems is 4 times 8, which would be 32 pixels. But we discussed that this would be very painful to do for every single element, so we just need to think as if it's 10 pixels, and continue to design for our base case. And then we would just iterate this value inside the browser until we land on a value we'd be happy with. Now I know this was a lot to take in, especially around some of the nuanced things happening with rems. But as usual, I'm going into a lot of detail so that you fully understand what's happening behind the scenes. And you'll soon see when we come and implement media queries on our Quill project, actually not that complicated. Next up, we'll explore how to define specific screen widths where styles change dynamically using breakpoints. We'll be discussing what are breakpoints and how to go about selecting breakpoints. So before we go and add media queries to our Quill project, we need to discuss what are breakpoints. Breakpoints are a specific screen width where a web page layout changes. Looking at this web page on the left, the browser width is currently at 981 pixels. You can see this same web page on the right, where the layout and elements have completely changed. This is at a browser width of 980 pixels, 1 pixel less than 981. You can see things like the font size changing and the positioning of elements like this image over here. 980 pixels is referred to as the breakpoint. That is, the point at which the website breaks to a new layout. So let's now discuss how we go about selecting breakpoints. Selecting breakpoints for specific devices is impractical as there are too many to cater for. We have mobile devices, where we have a range of different sizes. We have tablets, again with a range of different sizes. We have laptops that also come in a range of different sizes. And finally, desktops, which also come in a range of different sizes. Now, we don't design for specific devices, and when I mean specific, I mean something like an iPhone X or a Samsung Galaxy, because if we took this approach, we'd have to design for hundreds of different screen widths. So if we don't design for specific devices, how do we go about doing this? Well, knowing the ranges of common device screen sizes is helpful in thinking about breakpoints. Now, I do just want to highlight straight away that there is no universal standard when it comes to these ranges. These ranges are just a good framework for helping you think about breakpoints. So let's take a look at them now. We'll start on the right with large devices and move to smaller devices on the left. The first pixel value I want to look at is 1536 pixels. Anything bigger than this would be considered part of the large screens category. For example, an iMac 27-inch has a screen width of 2560 pixels. The next pixel value I want to look at is 1280 pixels. Between these two values would be our category of large laptops. An example of a large laptop in this range is the MacBook Pro 14-inch. which has a screen width of 1512 pixels. The next pixel value I'd like to look at is 1024 pixels, and this range is where our small laptops live. An example of a small laptop is a Dell XPS 13, which has a screen width of 1200 pixels. The next pixel value we're going to look at is 768 pixels, and this range contains our tablets. An example tablet is the 11-inch iPad Pro in portrait view. This has a screen width of 834 pixels. The last value we're going to look at is 576 pixels. Inside this range, we have phones in landscape. An example device is the iPhone 8 in landscape, which has a width of 667 pixels. This means the last range, which is anything less than 576 pixels, contains our phones in portrait. An example device in this category is the iPhone X in portrait, which has a screen width of 375 pixels. Where when we select breakpoints, it's a good idea to try select a breakpoint within these ranges, as it provides a helpful framework to ensure our web page does cater for these different screen types. Now, I said earlier that there is no universal standard. This is a framework I personally like to work with, but there may be others out there. Just to show you what I mean about there being no universal standard for these ranges, there are some devices that break these rules. For example, at 1366 pixels, we have the 12.9-inch iPad Pro. This is a large and high-resolution iPad that falls in the large laptops category. At the end of the day, it doesn't really matter, because the design we implement for the large laptop will be perfectly fine on this large iPad. So this framework is still very useful. Now, it's also common to give these ranges a more suitable name. So starting at phone portrait, we would call this XS for extra small. For phone landscape, we would call this SM for small. For tablets, we would call this MD for medium. Small laptops, LG for large. Large laptops would be XL for extra large. And large screens would be 2XL for 2 times extra large. Now, ultimately, selecting breakpoints should be design-led and determined by observing where the layout naturally breaks. So within these ranges, you just need to play around with your design to land on your actual breakpoints. So for example, a particular web page may have breakpoints that look like this. So it's not common to have your breakpoints at the line between different devices we saw in our framework, but rather you'll just play around with your design and pick a breakpoint that seems right to you, which will usually fall within the ranges. Let's take a look at an example of this. So I'm on this homepage. I'm going to open up DevTools, and I'm going to come click on the toggle device icon. This allows me to easily change the screen width of the web page and shows the width and height up here. So I'm currently at around 1800 pixels. The first range we looked at was anything above 1536 pixels. This was 2XL large screens. So let's go and approach that value, and you'll see there's no change. So the design we just saw above this value was for large screens. The next range for large laptops, which was XL, was 1280 pixels to 1536 pixels. So let's reduce the width and approach 1286 pixels. You can see at around 1300 pixels, the design breaks. Noticeably, the image reduces in size. So that breakpoint is in the range 1280 to 1536, which is the XL large laptops. The next range was 1024 pixels to 1280 pixels. This was the small laptops LG for large range. So let's go and approach 1024 pixels, and you can see that around 1110 pixels, the design changes. Most notably, the navigation bar changes. The next range of values was 768 pixels to 1024 pixels, which is our tablet's medium range. So let's go and approach 768 pixels. And you can see at this point here, around 893 pixels, the design once again breaks. The next range was 576 pixels to 768 pixels, which was for phones and landscapes, which was our small range. So let's go and reduce the width of our browser. And you can see in this case, the breakpoint is actually at 768 pixels, which was the line between small and medium. Now the last range was anything below 576 pixels, which was for phones in portrait, and was XS, extra small. Now in this case, this web page actually doesn't have a breakpoint in that range. The change you just saw there was simply the heading going onto another line. And the same thing here, the paragraph just goes onto another line. Now this is totally okay. You don't have to have a breakpoint at every single range. It's totally dependent on what you think works for your design. What I do want to show you though, is that at some point, when we go to really small pixel values, the design just completely breaks. You can see it around 200 pixels. We have this white line appearing down the side here. And you can see this is actually being caused by these buttons overflowing. Now, for such small pixel values, we're not really going to care about. The main thing I wanted to highlight was that this design does follow our framework in most cases, but in one or two places it doesn't, and that's totally okay. Selecting breakpoints is completely dependent on your design and what you think looks good. Just to show you another example of this, let's go check out the breakpoints on this page. I'll open up DevTools. I'm currently at 2000 pixels, which is very wide. Let's go reduce the width of the browser. Our first breakpoint is exactly at 1024 pixels. So effectively, this design has grouped small laptops, and large screens all together. That is, anything above 1024 pixels, which again is totally fine. Let's go find the next breakpoint. That's at 768 pixels. So this design seems to be following the exact breaks in the framework that I provided. Let's go find the next breakpoint. And you'll see that is in fact the last breakpoint. So this design only has 2 breakpoints. Now this does work, but my general advice would be to have more than 2 breakpoints. You probably want to have a minimum of around 3 or 4. Now the last thing I need to point out is that when using max width in media queries, there's no need to set a maximum range because styles will be applied automatically. Let's take a look at this in the diagram. Inside our media queries, these breakpoints would appear in our CSS like this, where you can see the largest max width value is 1600 pixels. Now anything larger than this is when our styles are not inside any media query and are applied automatically. So I just wanted to highlight, for whatever design you have for your largest screen type, those don't appear in a media query. The value of your first media query in your CSS is effectively the start of this larger screen type and also functions as the end of your large laptop. In this case, it's a max width of 1600 pixels. What this means is that the first screen type you'll be designing for is a large laptop, as the large screen is the default case you would have already designed for. So let's wrap up this chapter by adding to our summary card responsive design. In this chapter, we looked at breakpoints. A breakpoint is a specific screen width where a web page's layout changes. We saw these useful values, which provide us a range to keep in mind when selecting our breakpoints. Larger than 1536 pixels is for our large screens, which is 2XL. Between 1280 and 1536 is our large laptops, which is XL. Between 1024 and 1280 are our small laptops, which is large. Between 768 and 1024 are our tablets, which are medium. Between 576 and 768 are our phones in landscape, which are small. And anything less than 576 are phones in portrait and are extra small. Alright, so I'm back inside our Quill project, and let's start off by looking for our first breakpoint. I'm going to open up DevTools, and from the framework we looked at earlier, the first value we want to go to is 1536 pixels. So I'm going to head to that width, and anything above here is just our default case for large screens. Let's now start heading towards our next value, which was 1280 pixels. Now for me, I'm actually okay with this. I don't think the design is breaking at any point, and still looks good. So I'm actually going to skip that range. That is 1280 to 1536, which covers our large laptops. I'm now going to head to 1024 pixels, and I want to stop around here. The hero section looks good, but for me being pedantic, I don't love how this paragraph is now wrapping onto another line. If I expand it a bit more, you can see it's on 3 lines, and when I get to around 1138 pixels, the word clicks wraps onto another line. And for me, this just looks like a bit of a chunky paragraph. Now the horizontal space is also becoming limited, I also want to reduce the column gap between our group text and image inside our grid. And when I scroll down, for me this gap between our CTA card and the footer is just too large. The large space looks good on large screens, but on smaller screens, it's kind of a bit pointless to keep scrolling down just to hit a footer. So the first breakpoint I'm going to choose will be around 1150 pixels. I want to pick that value to ensure I'm a bit above where this word clicks is wrapping onto another line, which is around 1140 pixels. So 1150 is a good breakpoint for me to work with. And this breakpoint covers me for small laptops, that is between 1024 pixels and 1280 pixels. So let's jump into VS Code and code this up. Alright, so I'm back inside our app.css file for our Quill project. Now in the demonstration I did earlier, we came and added our media queries at the bottom of the CSS file. Now instead of doing this, it's a much better idea to start a new CSS file which just contains our media queries. So I'm going to go to our file structure, I'm going to go right-click New File and create a new CSS file called queries.css. I'm going to head to index.html, and under our main app style sheet, I'm going to come add our media queries. I'll grab the link tag and look for queries.css. Now, it's really important that this appears after app.css because we first want all our global styles, our components, and different section layouts to load in first. And then the queries come and handles any specific screen sizes once all these styles have loaded in. Doing this also makes coding our media queries much easier. What's really nice to do is have our app.css on the left and move our queries to the right. So on the left, we can toggle between our HTML and main CSS styles, where we pinpoint anything we want to change. And on the right, we just come and add our query. So the first thing I'm going to do is come add a comment. I'm going to have these comments serving as different headings for our different ranges. The first range we're designing for is large, which is for small laptops, which covers the range 1024 pixels to 1280 pixels. So let's come and add our media query. We grab the app rule, add max width, which I'm just going to leave blank for now, and add our curly brackets. So let's now work out the max width. We wanted our page to break at 1150 pixels. Now, as I've mentioned in an earlier chapter, the rem value in here is always based on the default browser font size, which is 16 pixels. So let's go and divide this by 16 pixels, and this gives us a value of 71.875. Now, I generally like rounding up my values, so instead of using this rem value, I'm just going to round this to 72 rems. Just so I know our final breakpoint, 72 rem by 16 pixels equals 1152 pixels. So you can see it's just slightly above the breakpoint we're targeting. So I'm going to come here and add 72 rem. I'm just going to leave these comments here, so when we look back at our file, we know how we calculated our breakpoint. So the first thing we're going to do is grab the HTML root element. Looking in our main CSS file, the font size on the root HTML file is currently set to 62.5%. And as we know by now, when we change the root HTML font size, this changes the value of a rem. And we know that this is a nice, quick and easy way to scale all values using rems as the screen size reduces. The properties using rems are mostly font sizes, as well as different spacing properties, like padding and margin. So our base case is a font size of 62.5%. As a reminder, this is equivalent to 10 pixels. The 62.5% was calculated by dividing 10 pixels by the default browser font size of 16 pixels to give us 62.5%. In this media query, I want the default font size to reduce to 9 pixels. So 9 pixels divided by 16 pixels equals 56.25%. So let's come and update the font size of the root HTML element to 56.25%. So let's check out how this has changed our web page. So our breakpoint is at 1152 pixels. So let's head towards that value. You can see when I hit it, the font size and all spacing properties reduce. Let's check it out over here. You can see the font size has reduced. And just to see how the spacing changes, let's check out the margin between the features section and the CTA. You'll see this slightly shifts up as the margin has reduced. So that's a fairly common first step, to come and reduce the font size of the root HTML element, so all values that use rem scale down. We then look at our design and fine-tune any other areas we want to change. For me, this column gap is still too small. I want our image and group text to appear closer together. And also, this distance between our CTA section and footer is also too large. So back inside our CSS, the first thing I want to go change is that column gap. Let's go find it in our CSS on the left here. Inside our features section, you can see we're defining column gap here of 5 rems. So I'm going to simply copy this class, paste it, and I'm going to go override the column gap property with a new value. As we discussed earlier, the rem value inside this media query is now based on 9 pixels. But in my head, I just continue designing for our base case of 10 pixels. Let's start by making this 3 rem. So I'm thinking again of this as 30 pixels. And I can rest assured that my media query is just going to scale this down based on the new 9 pixel rem value. And honestly, this doesn't really matter because we're going to go look in the browser anyway to see what value we want to use. So let's check this out in the browser. I'll refresh. For me, this is looking better, but I'd still like to reduce this further. Jumping back in the CSS file, I'm going to update this to 2 rem. I'll refresh, and for me, this is now looking good. Our group text and images are a lot closer together for this smaller screen. The last thing I want to handle is this margin over here. Heading back to app.css, this is currently being handled in our CTA section with margin bottom of 30 rem. So I'm going to copy the CTA section class, and I'm going to change the value to margin bottom of 25 rem. Again, I'm just thinking of this as 10 pixels, so 250 pixels. And as I mentioned already, it doesn't really matter because we're just going to go check it out on our page anyway and see if we're happy with it. I'll refresh, and this is starting to look better. Our footer is moving closer to our CTA section, but I'd still like to reduce this. So I'm going to change this to 20 rem. I'll refresh, and for me, this is now looking good. There's still space between our footer and CTA section, but it's not like I have to scroll down just to be shown a footer. Now, this iterative process I just went through is very common. You start off with a particular value you think will work, and you just iterate with values until you find something you're happy with. Alright, so let's start looking for our next breakpoint. The next range of values was between 768 pixels and 1024 pixels. That is medium and tablets. So let's start heading towards 768. Now you'll see here this paragraph text is left aligned and not centered. This is actually an issue in our base CSS file, but so far this is looking okay. Let's scroll down to our features section. We'll play in this range again. And for me, around here, you can see our heading is wrapping onto 3 lines. And again, this paragraph text is just looking a bit too chunky for me when it's wrapping onto multiple lines. You can see the word clicks is wrapping onto this line around 810 pixels. So I'm going to pick a breakpoint at around 815 pixels. At this breakpoint, I want our font size to scale down. And just so that everything's consistent, we're also going to scale down the different spacing. So let's head back to our queries.css file. We'll grab app media, grab the max width property. I'll leave this value empty for now, and let's work it out. We want our breakpoint at around 815 pixels. We divide the root element's font size of 16 pixels to get 50.9375. Now again, I'm just going to round this up to 51 rem. Just so we know our final breakpoint, 51 rem times 16 pixels is equal to 816 pixels. So for max width, we're just going to pop in here 51 rem. In the previous media query, I changed our font size to 56.25%, which represents 9 pixels. And in this case, I'm going to change it to 8 pixels. 8 divided 16 is 50%. So I'm going to come and update our root element font size to 50 pixels. Let's check this out in the browser. So I'm going to come and approach 815 pixels, and you can see how our font size and spacing reduces. For me, the main thing is these headings look a lot nicer, not wrapping onto 3 lines. And all spacing has scaled down because our margin and padding is all in rems. So let's take a look at what we have so far. We have our large screens and large laptops grouped together. At 1152, we have our first breakpoint. And now at 816 pixels, we have our second breakpoint. Now at this breakpoint, I actually don't want to change anything else. I'm happy with how it looks. So all I've done for this breakpoint is change the root HTML font size. Now just before I forget, I'm going to come and copy this comment just to better organize this query's file. The range we just covered was MD for medium. This covers tablets and is the range 768 pixels to 1024 pixels. The breakpoint we selected was 816 pixels, which falls nicely between this range. Alright, before we move on to the next breakpoint, I do just want to fix up this issue with our text here. At the moment, it's aligned left, which wasn't an issue for larger screens because we're using Flexbox to center this. However, when the width of the Flex container is smaller than the width of the text, it's wrapping onto a second line. And we now actually want to center this text inside this Flex item. Inside our main CSS file, in the hero section, we have this class hero paragraph. I'm just going to come here and add text align center. Let's check it out in the browser, and you can see now our text is nicely centered inside this Flex item. Alright, so let's start looking for a breakpoint in the next range. The next range is 576 pixels to 768 pixels, which covers phones and landscape and is our small range. So let's start heading towards 576 pixels. I think this is all looking okay, but I'm going to scroll right to the bottom, and you can see that the CTA card is not looking great now. We have the word now wrapping onto a second line. This is all being caused by just too much padding on the CTA card. At this screen width, I also think the gap between our grid rows is too large. And because horizontal space is becoming very limited, we should reduce this column gap as well. I also think this distance between the features section and the CTA card is also becoming too large. And once again, our different features heading text is starting to wrap onto 3 lines, with this paragraph now wrapping onto 5 lines. So we should look at reducing all font size, as well as generally scaling down our margin and padding across the entire web page. So just to land on an exact breakpoint, you can see around 670 pixels. The word now is beginning to wrap. I'm going to use that as my reference for where I want the design to break. And I'm just going to pick a pixel value slightly above this of 680 pixels. So I'm going to grab this comment. I'll paste it here. The range we're designing for is now small, which is phone in landscape. The range is 576 pixels to 768 pixels. I'll grab our media query, add the max width property, leave it blank for now, and add our curly brackets. The breakpoint we selected was 680 pixels. To work out rems, we divide by the default browser font size of 16 pixels, which gives us 42.5 rem, which I'm going to round up to 43. Just so we know our final breakpoint, 43 rem times by 16 pixels is equal to 688 pixels. So let's pop in our breakpoint of 43 rem, and like usual, I'm going to grab the root HTML element, and I now want to work with a rem value of 7 pixels. 7 divided 16 is 0.4375, which is 43.75%. So let's come and change the 50% to that value there. I'll save, and let's check this out in the browser. So let's go towards our breakpoint of 688 pixels. So you can see this has had a big impact. Our heading and paragraph don't wrap as much. And most importantly, the CTA heading in the CTA card is looking better. However, I would still like to reduce this padding. For me at this screen width, it's just too excessive. So let's go find that class in our CSS. We have CTA card over here with this padding property. I'll copy CTA card. I'll grab the padding property, and I'm going to override these values to something like 8 rem and 16 rem. Let's check this out in the browser. All right, for me, this looks a bit better, where you can see when I get close to the edge of this range of 576 pixels, it's still not wrapping onto a second line. Now, as I mentioned, I also want to reduce the margin between our features section and CTA. In our CSS, that's currently being set over here with the features section class. I'll copy that. The rem value here is 30 rem. So I'll grab margin bottom, and I'm going to change to something like 20 rem. I'll save. I'll refresh, and you can see this distance now looks a lot better. Let's now go handle the grid. I want to reduce the row gap, and I want to continue to reduce this column gap. In the features section, we have row and column gap being set here. I'll copy this class. Let's do the row gap and change it to a much smaller value like 5 rem. For column gap, I want to reduce this very small to something like 0.5 rem. I'll save. I'll refresh, and you can see this content now is a lot more contained for this screen size. All right, just taking one more look at it. Yep, I think this looks a lot better. All right, we're on to our final breakpoint. We're now looking at the range less than 576 pixels, which is for phones in portrait and is extra small. So I'm going to start reducing the browser. Now, this orientation does start looking like a phone. And there's two things I want to point out about the hero section. The first is this word "the" is just looking a bit odd on its own line. The reason that is happening is because we added a break tag after our for. So for small phones, I want to effectively remove that break tag. The other thing I'd like to do is no longer have our hero section above the fold. I would like to push it up and have some of this content below, now above the fold for a mobile in portrait. The other major thing we need to start looking at is that this grid layout is just no longer working. The screen width is too small to have this display nicely. We effectively want to remove this 2-column grid layout and just have our different grid items stack on top of each other. And once again, this padding is just getting a bit too much. And I'd also like to generally scale down our font size and general spacing of margin and padding on our web page. So let's go find a breakpoint. I'm going to be guided again about the CTA section. You can see around 520 pixels, the padding is too large and forcing the get started now to wrap onto a second line. So I'm going to pick a breakpoint of around 530 pixels, which is less than the 768 pixel range we're designing for. So let's head back into our query's CSS file. The first thing I'm going to do is copy this comment. We're now designing for extra small screens, which is a phone in portrait, and the range is less than 576 pixels. I'll grab our media query, add the max width property, just leave this blank for now. To work out the rem value, the breakpoint we decided was 530 pixels. We'll divide this by 16 pixels, which gives us a value of 33.125, which I'm just going to round up to 34. Just so we know our final breakpoint in pixels, 34 rem multiplied by 16 pixels is 544 pixels. So let's pop our 34 rem value into our media query. All right, I'm just going to copy this HTML rule. I'll paste it in here. I'm now going to reduce the font size to 6 pixels. So 6 divided 16 is 0.375, which is 37.5%. So I'm going to update our root HTML font size to 37.5%. Now, just a general rule of thumb, if my font size is now 6 pixels, if I go look at some of our text properties, our paragraph text is now 12 pixels. That is 2 by 6 pixels, because 1 rem is now equal to 6 pixels. Now, we probably don't want to be going much below this, having a paragraph font size of 12 pixels. So this is just a good little check you can do when your root element font size starts reducing to much lower values like 6 pixels. So I'll save this, and let's check out this change in the browser. Okay, so our font size has reduced, and spacing across the web page has reduced. All right, let's work top to bottom and start fixing some of these issues. The first thing I want to do is effectively remove this break tag sitting in our HTML, forcing the word "the" onto its own line. Let's check that out in the markup. You can see in our hero section main heading, we have this break tag over here. Now at the moment, that doesn't have a class. So let me just go add one. I'll give it the name hero heading break. I'll copy that. Let's select it. And we're actually going to be using the display property and set its value to none. We've looked at the display property in great length already, where we've seen the values like block, inline block, display, and flex. None is actually another value. And what this does is effectively hides this element from the web page. The element is still there in the underlying HTML. It's just when the browser renders, this rule says to the browser, just don't display it. So let's check it out. I'll refresh, and you can see on our web page, the break disappears. Just to show you, it is still in our HTML. If I go to this H1 here, you can see the break tag is still there, but the display none property is just hiding it from the browser. All right, the next thing I want to handle is effectively removing the view height unit we're using on our hero section so that other content, like the feature section, now appears above the fold. In our app.css file, if I scroll down to our sections, you can see the hero section currently has this calculation being performed where we set it as 100 view height units, and we're just subtracting off the height of the navigation bar. I'm going to come and select this class, and I'm going to change the height to auto. And what this now does is calculates the height of the hero section to be based on its content. So we're effectively overriding this height value here based on view height units, and we just say, make the height of the hero section just the content inside of it. Let's check this out in the browser. So you'll see now the view height units has been removed, and our feature section now appears above the fold. Now, of course, you didn't have to do this. I did just want to show you how you could achieve this. Okay, let's scroll down our page. The next thing we need to take care of is this grid layout, where we want our group text and our images to now stack on top of each other and no longer be in a 2-column layout. I'm going to go to our features section. At the moment, the column layout is being defined by this grid template columns. I'm going to copy this class. I'm going to grab the grid template columns property, and I'm now going to change it to a single column by just having one fractional unit. Let's see the effect of this in the browser. I'll refresh, and you can see this now looks a lot nicer. We have our group text and our image, but you can see we have a small problem. Over here, we have our group text and image, but then over here, we have our image and group text, and then we're back to our group text and image. The reason this is happening is because of this rule over here, where on larger screen size, for the second row, we were swapping the order of the image so it appeared on the left. But this is now messing with this view here. So we effectively want to cancel these out. To do that, I'm going to grab this class, I'm going to grab the grid row property, and I'm going to set its value to auto. This essentially just resets the grid row property to its default value. And then I'm going to do the same for grid column. So all we've done here is effectively reset it to the default placing that it would appear in the HTML. And if I check out our HTML, this is ordered correctly. We have group text followed by image, group text followed by image, and group text followed by image. And this is exactly how we want it to appear on our web page on a smaller screen. So let's check it out in the browser. I'll refresh, and you can see this is looking great. We have group text followed by image for each feature. Okay, the last thing I want to take care of is just the padding on our CTA. I actually want to start reducing the horizontal padding a lot more than the vertical padding. In our queries file, I'm just going to grab the CTA card we did previously. I'll paste it down here. I'm actually going to leave the top and bottom padding value at 8 rems, but I want to significantly change the horizontal padding left and right to 6 rems. Let's check out the effect of this in the browser. I'll refresh, and you can see this now looks a lot nicer. There's a lot more horizontal space for the content in our CTA card. Alright, so that wraps up media queries on our Quill application. Let's go check out our amazing work for each section as we reduce the width of the browser. Okay, that looks fantastic. Let's go check out the features section. Alright, this is looking really nice, where the different font sizes and spacing changes for different widths and eventually breaks into a single column layout. For our CTA card, you can see this always maintains a good font size and padding value. The last thing I want to mention is that if I make this width really small, you can see the design does start to break a little bit. But the truth is, we just don't really care about values this small. Just to give you some kind of benchmark, the first version of the iPhone had a screen width of 320 pixels. Now, there's not many of those floating around anymore, but if you want to be really safe, 320 pixels is a very conservative value you can choose where your web page should still look good. And for me, this looks totally fine. But in all honesty, most small devices will be much larger than this. We'll finish off this topic by understanding how CSS units relate to real-world screen resolutions by understanding CSS and physical pixels. We'll be discussing what is a pixel, physical pixels, CSS pixels, and pixels in DevTools versus devices. So, what is a pixel? A pixel is a single point of light on a digital display. We have a digital display like a desktop, and this display is made up of thousands of pixels, which emit red, green, and blue light at different intensities to create different colors. Now, so far in this course, we've actually been assuming the size of a pixel is the same across all devices. Earlier on, I mentioned that the size of a pixel is 1/96 of an inch, which is 0.0104 inches. But in real life, on an actual screen, that is not the case, which is why we need to distinguish between physical and CSS pixels. Let's start with physical pixels. A physical pixel does not have a fixed length and varies between screens. Looking, for example, at a MacBook Pro 16-inch, this contains 3,456 pixels wide and contains 2,234 pixels high. A MacBook Pro 16-inch has a screen size of 16.2 inches. We can use these numbers to work out the size of a pixel, where one pixel will equal 0.0038 of an inch. This also gives us a metric called the PPI, which stands for pixels per inch. In the case of a MacBook Pro, it has a 254 PPI screen. The higher the PPI value means the more pixels you have in an inch, which means the sharper the screen will be. Let's compare this to a Dell Inspiration 15.6 inch. The screen size of this device is 15.5 inches. Now, this is a fairly similar physical size to our MacBook Pro, but the major difference here is that there are a lot less pixels. In width, there are only 1,920 pixels, and this is roughly half the number of pixels. For the height, there's 1,200 pixels, which is also close to half the number of pixels in height on the MacBook Pro. So, although the physical size of the screen is fairly similar, there are a lot less pixels in width and height. This means a pixel is going to be close to double the size of that on a MacBook Pro. On this device, one pixel equals 0.0071 inch, which is close to double the size of a pixel on a MacBook Pro. The pixels per inch value on a Dell Inspiration is 141 PPI. This is a lower number, meaning the screen won't be as sharp as the MacBook Pro. Now, what this means is that if we were to use physical pixel values in our CSS, we would run into some problems. For example, if I set a font size of 10 pixels, on our MacBook Pro, the text "Welcome Aboard" would be 10 pixels, which is 0.038 of an inch. That is 1 pixel, which was 0.0038 times by 10. On our Dell Inspiration, the "Welcome Aboard" text would appear a lot larger, where 10 pixels would be 0.071 of an inch. So, using physical pixels would result in inconsistent sizing of our elements on the page. So, to handle this problem, we have CSS pixels. A CSS pixel has a length of 1 divided by 96 of an inch. That is 0.0104 of an inch. So a CSS pixel does have a fixed width. So applying font size of 10 pixels means that our text will be the same. That is 0.014 inch on our MacBook Pro, which is the fixed CSS pixel length of 0.014 times by 10. And on the Dell Inspiration, the font size will be the same 0.014 inch. That is the fixed pixel length times by 10. Now the difference is that the number of physical pixels actually used between the devices will be different. So on our MacBook Pro, 27 physical pixels have been used on the Welcome Aboard text, whereas on our Dell Inspiration, only 14 physical pixels have been used to make this text. So to achieve this, browsers will scale the CSS pixels that we set to use the correct number of physical pixels on different screen sizes so that our elements are styled consistently. So once again, in our CSS, we're using a fixed length of 1/96 of an inch for our pixel. And then when our web page renders in the browser will work out the resolution of the screen size it's on, and then determine how many physical pixels need to be used in order to achieve the 10 pixel font size we set in our CSS. Now let me show you why I'm bringing this all up. I'm on this web page, and if I open up DevTools, we've so far been playing with different screen widths when using CSS media queries. Now we're currently in this responsive view, which allows us just to toggle the width and height as we please. But there are also these specific devices we can select. For example, a Google Pixel 7. This now models what our page would look like specifically on a Pixel 7. Now what I want you to see is that the dimensions we're showing are 412 pixels by 915 pixels. But when you go and check out the actual size of a pixel, you can see its resolution is 1080 pixels by 2400 pixels. That's very different to what's appearing here. So let's now talk about pixels in DevTools versus devices. Pixel values in DevTools are not the same as device pixel values. Inside DevTools, we're using CSS pixels. That is the fixed pixel of 1/96 of an inch that we're also using in our text editor. So looking at our Google Pixel 7, the CSS pixel is always 1/96 or 0.014 of an inch. Based on this fixed pixel length, the physical width of the phone would then be 412 pixels, and the height would be 915 pixels. In the background, the browser knows the actual physical dimensions of the phone, so you can work backwards for the browser to know how many CSS pixels this would be in width and height. Looking now at the actual device, this uses physical pixels. So for a Google Pixel 7, the physical pixel is 0.0024 of an inch, which means that there's 1080 pixels in width and 2400 pixels in height. Now, CSS pixels are scaled depending on the screen resolutions. Our Google Pixel 7 has 416 pixels per inch. So from DevTools to the physical device, in order for the browser to know how many physical pixels to allocate inside the device screen based on the CSS pixels that's defined in our code, the pixel is scaled by the device pixel ratio, the DPR. In this case, it would be multiplied by about 3. So what this means is if we have a font size set as 10 pixels in our CSS code, in DevTools, that would have a fixed width of 10 times 1/96 of an inch. And then in the device, to get that exact font size, the browser works out we need to multiply the number of physical pixels in the device in order to achieve that CSS font size. Now, scaling across different devices happens automatically. Inside DevTools, we have the setup we just looked at before using the CSS pixel. The Google Pixel 7 has a 416 ppi, which means that the length of a physical pixel is 0.0024. The browser knows to use 3 times as many physical pixels to achieve our desired sizing in our CSS. Now popping back into DevTools, I'm going to come and select a Samsung Galaxy S20 Ultra, and I want you to keep your eye on the dimensions 412 and 915. You'll see they remain unchanged. And if we then take a look at the physical dimensions of the Samsung Galaxy S20 Ultra, you'll see it has a height of 3,200 physical pixels and a width of 1,440 physical pixels, which is much larger than the Google Pixel 7, which has a height of 2,400 physical pixels and a width of 1,080 physical pixels. So let's check out what's going on here. So looking at the Galaxy S20 Ultra, it actually has a 511 ppi. It's 1,440 pixels wide and 3,200 pixels high. On the Galaxy, the physical pixel is a lot smaller than the Google Pixel 7 at 0.00196 of an inch. And again, the browser will automatically scale this, where one CSS pixel will use about 3.5 physical pixels. Now, the reason why in DevTools both the CSS pixels of the two devices was the same is because it just so happens to work out that if you divide each physical pixel dimension by the DPR, you get the same CSS pixel. So for example, if I divide the height of the galaxy by its DPR, it would be 3,200 pixels divided by 3.5, which would be around 915 CSS pixels. For the Google Pixel 7, if I divide its height of 2,400 physical pixels divided by its DPR, which is actually 2.625, I just rounded it up, you get the same CSS pixel value of 915 pixels. So for these two devices, it just so happens that their CSS pixel values are the same, even though they have different physical pixel sizes and screen resolutions. So let's finish off the summary card responsive design. In this chapter, we looked at CSS and physical pixels. CSS pixels are a fixed size, whereas physical pixels in devices do not have a fixed size. We saw inside DevTools, we're using CSS pixels, which has a fixed length of 1/96 or 0.014 of an inch. Inside an actual device, we're using physical pixels, where the pixel depends on screen size and resolution. And we saw that pixels are always scaled by the DPR, the device pixel ratio, to ensure sizing between different devices will be consistent. So long story short, when we're inside VS Code and DevTools, we're working with a fixed pixel of 0.014 of an inch, and then when it comes to the page being rendered in a browser, the browser will automatically calculate the number of physical pixels that are needed to match the CSS pixel of 0.014 inch inside DevTools and our text editor. And this is all done because the number of physical pixels across devices varies, and using a CSS pixel multiplied by the device pixel ratio ensures that the sizing of our web page is consistent across all devices. Now, I wouldn't stress too much about this chapter, as everything is calculated automatically between CSS and physical pixels. But like usual, I like going into the details so you have a solid understanding of what is going on behind the scenes. Great work, we've now finished responsive design. Now that you understand media queries, you're well equipped to build responsive websites that work across all different screen sizes. It's now time to move on to positioning. Positioning is a technique that gives you full control over the exact placement of elements on your page, helping you create detailed and precise user interfaces. As part of this topic, we'll also dive into stacking order and transformations to add depth and interactivity to your layouts. Let's begin by exploring how to precisely place elements on a web page using different layout techniques with positioning. We'll be discussing static positioning, relative positioning, absolute positioning, fixed positioning, and sticky positioning. So before we talk about positioning, I want to quickly talk about normal flow in a bit more detail. Elements occupy their own designated slot on the page, which allows them to be surrounded by other elements. So let's take a look at what I mean by this in diagram form. We have a container. Now we're going to look at block and inline elements, and I want to start thinking of these as being made up of kind of two parts. The first part of the block element is the slot. It's the area designated on the page for the element. We then have the element itself. So these would be block elements, where we have the slot on the page as well as the element itself. And the same thing for inline elements. We have the slot, that is the area on the page allocated for this element, and then the element in this allocated space itself. And these would be our inline elements. Now I know up until now, we haven't really thought about slots on the page, but rather just the elements being there. But for us to think about positioning, we now need to think of elements as being made up of two components. A slot, which is the area designated for the element, and then the element itself. So let's now talk about the position property. The position property determines how an element is positioned on the page. In CSS, it looks like this. Position is the property, and relative is an example of one of the values. The values we can have include static, relative, absolute, fixed, and sticky, where static is the default value. So let's first look at static positioning. Static positioning is when the element follows the normal document flow. In CSS, we have position static, where static is the default property. It's what we've seen so far, where elements just follow normal flow. In diagram form, we have 3 slots designated for our elements, and our elements just occupy these slots. These elements are block elements, so block elements will stack on top of each other like this. So let's check this out in VS Code. So I've gone ahead and created an index.html file and linked a style sheet which is currently empty. Inside the body, I want to go grab a div to act as a container. I'm going to give it the class container. And then in here, I'm going to add 3 divs. I'm going to number them 1, 2, and 3. And I'm going to add a class to each div. Box 1, box 2, and box 3. So we have a main container holding 3 divs. Let's head to app.css. The first thing I want to do is grab the universal selector and reset all margin and padding. I'm then going to grab the container. I'm going to give it a width of 800 pixels and a height of 800 pixels. Just so we can see it, I'm going to give it a background color of light gray. I'm also going to give the entire container a margin top of 100 pixels just to move it down slightly. And I'm going to give it a margin left of 100 pixels to move it right slightly. I'm also going to give it a font size of 40 pixels, which will be inherited by our different boxes. Let's go style the boxes now. I'll select box 1. I'm going to give it a height of 100 pixels, a width of 100 pixels, and just so we can see it, I'm going to give it a background color of light coral. I'm going to copy this rule, change it to box 2, change the height to 200 pixels, the width to 200 pixels, and change the color to light green. I'll copy this again, and for box 3, I'm going to give it a height of 300 pixels, a width of 300 pixels, and change the color to light sky blue. All right, let's check this out in the browser. Okay, nothing crazy going on. We have our main container in gray and our different boxes stacked on top of each other because they're block elements. Now let's go to block 2, add the position property, and give it the value static. If I refresh, nothing changes. Static is just the default value of all elements. And once again, what this means is that the element fills the slot it is allocated. Now I know this idea of slot may seem very new and not relevant at all, but let's now go and see this idea of slot and element by looking at relative positioning. In relative positioning, the element follows the normal document flow but can be offset relative to itself. In CSS, we would set position to the value relative. So looking at the green element, the element can move around relative to its original position. So what this means, we can separate out the element from its slot and move the element like this. So the slot remains, that is the area on the web page allocated for the element, but the actual element can move around the page. So let's get a better visual understanding of what's happening here. It's kind of like there's 2 layers going on here. All the other elements and slots are in one layer, where other elements remain in position as the slot of the relatively positioned element remains present. So in our first layer, because the slot is still there, the orange and purple elements stay in place, now with a gap between them created by the slot of the green element. And for the green element, this is now in its own layer and can move around. So how do we move this element around? We do this with offset properties. Offset properties are used to shift the element from its reference point. Now for this to work, the position property has a value other than static. So using offset properties wouldn't work for regular elements, because by default, regular elements have a position property of static. But the offset property does work when it has a non-static value, like relative and the other values we're going to be seeing soon. So for an element with the position relative, the reference point is the element itself. If you look at the green slot on the left, the reference point will be the top left of the image shown in red. And we can add in axes at this point. This is the reference point of the element. And it's easiest to think of this in the top left of the element. So let's go check out the offset properties. There's 4 of them. The first offset property is top, and in this example, it has a value of 20 pixels. Now for me, I find these values a little bit counterintuitive. So to help, I've come up with this sentence for how to think about them. So for the case of top, what this means is that you shift whatever the value is, in this case 20 pixels, away from the, and then the property top of the reference point. So let's read that out again. If you applied top 20 pixels to the element, what this would do is shift 20 pixels away from the top of the reference point. I just find it a bit confusing if I don't think of it in this sentence, because it's about moving the direction away from your reference point. We have left 10 pixels, and converting this to plain English, it would mean we're shifting 10 pixels away from the left of the reference point. We have bottom 40 pixels, which means we're shifting 40 pixels away from the bottom of the reference point. And we have right 30 pixels, which means we're shifting 30 pixels away from the right of the reference point. So let's go play around with these inside VS Code. All right, so picking up where we left off, I'm going to come to box 2 over here, and I want to change its position value to relative. I'll refresh and you'll see there is no change. But what's happening behind the scenes is that the element is now in its own layer, and the slot remains in place. Now that we've added position relative, we can go use our offset properties to move the element around in its own layer. Let's go add top of 30 pixels. And the way we need to read this again is we shift 30 pixels away from the top of the reference point. I'm going to think of our reference point as the top left here. So we're moving 30 pixels away from the top, which effectively means we're going to be moving down. If I refresh, you'll see our element moves 30 pixels down. Now, this is why I find it a bit counterintuitive, because you may just look at this and think top means you move up. But in fact, you're moving the opposite direction. And that's because you're moving away from the reference point, where once again, the reference point is the slot of the element. Let's go add the left offset and set a value of 40 pixels. The way we read this is that we're shifting 40 pixels away from the left of the reference point. That is, we're going to be moving right. So I'll refresh, and you can see now we've moved 30 pixels away from the top of the reference point and 40 pixels away left from the reference point. Now I'm going to change the position property back to static, which is just a default value, and you'll see the offset properties do not work. And that's because the offset properties only work when the position value is anything other but static. Now, I really want to highlight for relative positioning, the slot still remains in place, and the offset properties move the element relative to its original positioning. That is where the slot is. So let's now take a look at absolute positioning. In absolute positioning, the element is removed from the normal document flow. In CSS, we are positioning with the value absolute. Let's take a look at this in diagram form. We're going to be focusing on the green element, and when we set position absolute, the actual slot of this element is entirely removed from our web page. So what this means is that any elements below it can now occupy that space. It's very different to relative positioning, where there, the slot of the element did remain in place. Whereas for absolute positioning, elements below move in as the slot is no longer present. So just like relative positioning, our green element is in its own layer now. Where in our first layer, the green box does not exist for these elements as the slot has been removed. The green box is in its own layer and can move around, using the same offset properties. So let's jump into VS Code and play around with this. I'm just going to remove the offset properties on box 2, and I'll refresh to get the element back in its original position. Now this is still positioned relatively, where we discussed for relative position elements, the slot remains in place. Let's go change this now to absolute. I'll refresh, and you'll see the slot of box 2 has been completely removed. And what that means is that the element below box 3 can now occupy that space, where box 2 is now in its own layer. All right, I now want to spend a bit more time talking about the reference point for absolute positioned elements. When positioning an absolute positioned element, the reference point is the root HTML element. So on our page, we have our root HTML element, we have our div parent container, we have our 2 boxes in layer 1, and we have our green box in layer 2 absolutely positioned. Now the reference point when using offset properties is the entire root HTML element. The reference point are the edges of the root HTML element. We can't think of it as a single point with an X and Y axis like we did with the offset properties for relatively positioned elements. So for example, if we applied a left offset of 100 pixels, this would move our green element 100 pixels away from the left edge of the HTML root element. So it would end up over here. If we applied top of 50 pixels, this would move our element 50 pixels away from the top edge of the root HTML element. In this case, effectively moving it up. So for absolutely positioned elements, we're looking at the edges of the root HTML element, whereas for relatively positioned elements, this was the top left corner of the element itself. Let's play around with this inside VS Code. All right, so picking up where we left off, let's go add the offset property top and give it a value of 400 pixels. What this is going to do is move our green element 400 pixels away from the top of the HTML element. I'll refresh, and the distance from here to here is 400 pixels. Let's go move it left 300 pixels. This is going to move the green element 300 pixels away from the left edge over here. I'll refresh, and the distance from here to here is 300 pixels. Let's go change top to bottom. This will move our green element 400 pixels away from the bottom edge of the root HTML element. I'll refresh, and the distance from here to here is 400 pixels. Let's go change this to right, and this will move the element 300 pixels from the right edge of the HTML element. I'll refresh, and the distance from here to here is 300 pixels. I also just want to show you can use percentage values here. So for example, if I change this to 50%, what this is saying is move the green element 50% the width of the root HTML element from the right. I'll refresh, and the distance from this edge here to the edge of the root HTML element on the right is 50% the total width of the root HTML element. All right, I'm just going to change this back to pixels, but I do just want you to be aware you can also use percentages. Now, where absolute positioning gets a bit confusing is that the reference point can actually change. More commonly, the reference point is set by the nearest ancestor with a non-static position. All right, that's a bit of a mouthful. Let's break this down. What we can do, for example, is on our div parent container, change its position to relative. By having a non-static position property, like relative, on our div container, we'll now make this the reference point. The div is closer in the HTML document structure to the green element compared to the HTML element. So the closest non-static ancestor, in this case the div, will act as the reference point. So if we applied the offset properties now, let's say left 100 pixels, this will move our green element 100 pixels from the left edge of the div, and top 50 pixels will move our element 50 pixels from the top edge of the div. So the reference point has completely changed. Let's go play around with this inside VS Code. All right, so by default, like we saw earlier, the reference point is the root HTML element. But let's go and add position relative onto our div container. I'll refresh, and you'll see that the element shifted positions. And that's because the reference point is now the div container. Just to walk you through this, I'm going to remove these properties here. I'll refresh, and our absolutely positioned green element moves back into its original position. Let's go add left of 200 pixels. This will now move our green element 200 pixels away from the left edge of our gray container. I'll refresh, and the distance from here to here is 200 pixels. Let's go add a top of 10 pixels. What this will do is move our green element 10 pixels away from the top edge of our gray container. I'll refresh, and the distance from here to here is 10 pixels. We can even change these values to 0. So for example, setting 0 here will have no distance from the left edge, and setting 0 here will have no distance from the top. So it's moved to the top left corner. We can do the same thing by moving it to the bottom right. We can change right to 0 and bottom to 0. And this will move the element to the bottom right of the gray container. So this may seem a bit confusing, but it is fairly common to do this, where all we're doing is setting a position relative on a much closer parent, which kind of acts as an anchor point to reference the element we want to absolutely position. We're not using position relative on our container to move the container around. We're just adding position relative here in order to use the gray container as our reference point for box 2. Just see this declaration as kind of anchoring the container to be our reference point. All right, let's now talk about fixed and sticky positioning. Fixed and sticky positioning are kind of like special cases of absolute positioning. Just as a recap, for absolute positioning, the element is removed from the normal document flow, where we saw any elements below it could now occupy the space of where the original element was. This was different to relative positioning, where the slot of the element remained in place. So let's first look at fixed positioning. This is absolute positioning, but the element remains fixed relative to the viewport and is unaffected by scrolling. So in a nutshell, it's absolute positioning, but it's fixed to the viewport. Let's jump into VS Code and check this out. So we have our position absolutely positioned, where our reference point is the gray container, because it is the closest ancestor with a non-static position property, which kind of acts like an anchor. Now what I'm going to go do is change the height of the container to a much larger value, like 1500 pixels. I'll refresh, and as you may expect, our element still remains 0 away from the bottom edge of the container and 0 away from the right of the container. Just to better see this on the container, I'm just going to go add some margin bottom of 100 pixels. Now I'm going to go change the position of absolute to fixed. I'll refresh and you'll see straight away our element is positioned relative to the viewport. That is our browser. So it is absolutely positioned, that it still has been removed from normal flow. The reference point, however, changes to the viewport, that is the browser. And the other major difference is that this element now remains fixed when I scroll. So I'm going to scroll up the page and you can see it remains in the bottom right. So once again, a fixed positioned element is like absolute positioning in that the element is removed from normal flow. And that's why the 3 shifts up to occupy the original space where the 2 was. But the two subtleties of fixed versus absolute is that the reference point is the viewport now, and when I scroll, it still remains fixed in place. So let's now take a look at sticky positioning. In sticky positioning, the element is in normal flow until a certain scroll point when it then becomes fixed. So it's like fixed positioning, but it needs activation by hitting a certain scroll point, and actually remains in normal flow until we hit this point. Let's check this out in VS Code. Okay, so on box 2, I want to come remove the offset properties here and just set a top of 0. I'm going to leave position fixed for now. I'll refresh, and this now moves our element 0 pixels away from the top of the viewport. That is this top edge of the browser here. It's absolutely positioned, so its original slot has been removed, and fixed positioning means that when I scroll, it remains fixed in position relative to the viewport. Let's go now change this to sticky. I'll refresh, and you'll see the element actually goes back into its original position in normal flow. But when I now scroll, such that the element is 0 pixels away from the top of the viewport, that is the top edge of the browser here, it then changes to fixed, where when I scroll, it remains 0 pixels away from the top edge of the browser. So sticky is like fixed, however, it initially remains in normal flow until I hit an activation point by scrolling set by the offset property. So once again, it's in normal flow. I continue to scroll. When I'm 0 pixels away from the top edge of the viewport, it now becomes fixed. And of course, you can change this value. Let's make it 100 pixels. I'll refresh. And now when I'm 100 pixels away from the top edge, so about here, you'll see the element now becomes fixed. So let's now take a look at some positioning guidance. Absolute positioning is more commonly used than relative positioning because it removes elements from the document flow. This is preferred because the slot is removed, so there's no unexpected gaps in the layout. Looking at an example, we have this container over here, and we have these visual elements which would have the property position absolute and be positioned relative to the parent container. That is the blue div. For the next piece of guidance, absolute positioning should be used as a last resort for very specific cases, as it makes responsive design more challenging. So looking at this page over here, the star icon on the right of the image looks absolutely positioned. However, this is actually being achieved by Flexbox. Our image is a flex item, and the star is a flex item, and Flexbox properties would allow us to achieve this result. And using Flexbox is much more responsive friendly. So we rarely try avoid using absolute positioning unless we have to. More commonly used is fixed and sticky positioning. Fixed positioning is used for elements that need to be absolutely positioned, but also need to remain visible when the user scrolls. An example of an element we would want to remain visible when the user scrolls is something like this chat window over here. I'm sure you've had this experience where on a page, as you scroll down, the little chat box icon follows you down the page. Now in reality, you wouldn't actually be making this yourself, but you would be embedding code from a third-party chat provider like Intercom, and the code you embed would automatically have the fixed position property, so it goes to the bottom right and remains fixed. Sticky positioning is ideal for navbars as they stay at the top in normal flow and then become fixed when the user scrolls. Looking at this page over here, our navbar is initially in normal document flow, that is, it occupies its slot, but the navbar then becomes fixed when the user scrolls down. So for a navbar, we do want it to initially remain in normal document flow. We want the navbar in its original slot. But sometimes we want our navbar to remain at the top of the page when we scroll. And this is a perfect use case of sticky positioning. and we even classify our navbar as a sticky navbar. So let's wrap up by building the next summary card, positioning. I'm going to be summarizing everything we learned in this simple table, where I have the row headings, the value, a description of what's happening, what happens in document flow, how offset works, and a simple diagram. Let's look at static first. This is just the default positioning, where the element is in normal flow. For offset, it's ignored. You can't apply offset properties to a static positioned element. In diagram form, our block elements will just stack one on top of each other. The elements occupy their slots. For relative positioning, the element is positioned relative to its original position. The element remains in normal flow. That is, the slot of the element is still there. Offset properties can be applied. Looking at this in diagram form, if we set our green element to have a position relative and applied the offset properties left 100 pixels, the element will move 100 pixels away from the left of the reference point. That is 100 pixels to the right. If we then set top as 50 pixels, the element will shift 50 pixels away from the reference point. That is 50 pixels down from the element's top left corner. So our relatively positioned element ends up looking like this, where its original slot remains in normal flow and it's positioned relative to itself. That is, its original position. For absolute positioning, it's relative to the nearest non-static element, and if there are none, it's the root HTML element. However, we saw it's more common to anchor a parent element with the position relative property, so that we can position our absolutely positioned element in relation to that parent element. When absolutely positioned, the element is removed from normal flow, and offset properties apply. In diagram form, our green element is absolutely positioned, so its slot is removed, and the reference point is the closest non-static parent, where instead of an actual point, we think of the parent's edges. So applying offset of left 100 pixels and top 200 pixels will move our element 100 pixels away from the left edge and 200 pixels away from the top edge. For fixed positioning, it's relative to the viewport. The element is removed from normal flow, just like an absolute positioned element, and offset properties apply. So in diagram form, we have our fixed positioned element, which is just like an absolutely positioned element, in that it's removed from normal flow, but the offset properties are now relative to the viewport, where right 50 pixels and bottom 50 pixels will move our element here. That is, 50 pixels away from the right edge of the viewport and 50 pixels from the bottom of the viewport. The other big difference for a fixed element compared to an absolutely positioned element is that when the user scrolls, the element will remain in place. The diagram on the right represents the user scrolling down the page, where the orange element is no longer in view of the page. Finally, for a sticky positioned element, it starts static but becomes fixed after scrolling to a certain point. In terms of document flow, it starts in normal flow but is removed at a certain scroll point. And for sticky positioning, the offset property is actually required, so the browser knows at which point to make it sticky. In diagram form, our green element is initially statically positioned in normal document flow. Our reference point, just like fixed positioning, is the viewport. We set an offset property like top of 0, and when the user scrolls such that the element is now 0 pixels away from the top of the viewport, it then becomes fixed. So sticky positioning is fixed positioning, but the element initially is statically positioned until we hit a certain scroll point as set by the offset property. Okay, let's go see how we can use positioning in our Quill application. Now, just as a heads up, I'm actually happy with where the homepage is currently at. For me, it's perfect. It's looking really nice. And in the previous chapter, we also implemented media queries to ensure that the page is fully responsive for different devices. So me personally, I'd stop here. I think the page is looking great and doesn't need anything further. However, in this chapter and the next chapter, I am going to come and add more, just so we can implement what we have learnt on our project. So the first thing I'm going to do is come and add a little chat window in the bottom right here. And I want it to be fixed so that when I scroll, it always remains in the bottom right, in order to easily contact support. Now, as I mentioned previously, you wouldn't actually code this up yourself. You would just copy and paste some existing code from a third-party chat provider. But just to put positioning in action, let's go code this up. I'm going to head over to Ion Icons, and I'm going to search chat. I like this filled one here, so I'll click it and download it as an SVG. Okay, from my downloads folder, I'm just going to rename it to chat.svg. I'll copy it and paste it into the images folder in our Quill project.
Okay, I'm back inside our Quill project. Let's just double check the image is there. In our file directory, I'll go to images and we can see chat.svg. All right, so the first thing I'm going to go do is add the chat SVG to our HTML. I actually want to do this completely outside our different sections because this layer is kind of going to be floating above our different page sections. I'm going to come right to the bottom here, just before the closing body tag. I'm going to grab the image tag. The source is images/chat SVG. I'm going to give it some alt text of chat icon, and let's give it a class of chat-icon. I also want to wrap this image inside a div container, as I also want to be using Flexbox to nicely position this chat icon inside a background circle. I'm going to give this the class of chat container. All right, let's head over to app.css. I see this chat icon as a bit of a component as it could appear in other pages. So I'm going to scroll down to our components, and I'm just going to put it as the last component. I'm going to grab chat container. I'm going to give this a height of 7 rem, a width of 7 rem. Let's give it a background color. We'll grab the primary tint color, that's that lighter version of the primary color, and give it a border radius of 50%, which will make this chat container a circle. Let's check this out so far in the browser. Okay, so you can see our chat container with the blue background, with the chat icon inside of it, is just appearing in the bottom left, below our footer. That's just because in our HTML, it comes after our footer, and it's also not within the main page container, so it appears in the bottom left. All right, so let's first of all go make this chat icon a bit smaller. I'm going to grab the chat icon. I'm going to set its width to 5 rem and its height to 5 rem. I'll refresh, and you can now see the chat icon is smaller than the background blue circle. I'd like to nicely center this chat icon. Because the image is a child of the chat container, we can use Flexbox to easily center it. On the chat container, I'm going to go display flex. Our main axis is running from left to right, so we'll use justify content with the value center to center it horizontally, and align items with the value center to center it vertically. So our chat icon is now nicely centered inside our blue circle container. I also just want to change the color of the chat icon to be our primary blue. An easy way to do this is to open up the SVG, and we can just add a fill attribute and set its value to our primary blue. I'm going to scroll up where our primary blue base is this hex code over here. I'll copy it and paste it as our fill. I'll refresh, and you'll see our chat icon is now our primary blue. Heading back down, so let's now go fix the chat icon so that it appears close to the bottom right of the page. I'm going to add position with the property fixed. I'm going to give it a bottom value of 2 rem. This means that the chat container will be 2 rems from the bottom of the viewport, and we'll add right 2 rems, which means that the chat container will also be 2 rems from the right edge of the viewport. I'll refresh. You can see we now have our chat container nicely positioned in the bottom right. And when I scroll, it remains in place. So once again, I personally wouldn't go and add this to our project, but I just wanted to implement something using the position properties we've just learnt about. Next up, we'll learn how elements are layered on top of each other and how to control their depth using Z-index and stacking context. We'll first look at Z-index and then stacking context. So to understand the concept of Z-index, let's first recap normal flow. Most web layouts have elements in the same 2D plane and do not overlap. So we can think of our web page as having an x-axis and a y-axis. There's no z-axis, so this is just a 2D plane. And inside our plane, we have our elements. In this diagram, I'm going to have 3 divs. This orange div, this blue div, and this red div. The elements are in the same plane, and they're not overlapping. However, elements can overlap in the same plane, with the stacking order being determined by the order they appear in the HTML. Looking at our diagram, the blue div appears after the orange div in the HTML markup. So if this were to overlap the orange div, it would appear on top. The red div appears below the blue div in the HTML markup. And because of this, if it were to overlap the blue and orange div, it would appear above them both, because it appears last compared to these 2 elements. Let's go play around with this inside VS Code. So I'm back inside the file we looked at in the last chapter. At the moment, our box 2 is set as sticky. So when I scroll down, it remains fixed. I'm going to go remove the positioning properties here and just remove the position relative on the container. I'll refresh and we're just back to our box setup. Okay, I'm going to go to box 2, and I'm going to go add a margin bottom of minus 80 pixels. I'll refresh and watch what happens. This kind of does the opposite of making space between elements. It now essentially creates space for box 3 to move up by 80 pixels. And you can see that box 3 is now on top of box 2. If we look at the original markup, box 3 appears last, so therefore, when it overlaps box 2, it will appear above. I'm going to remove this and refresh. I'm now going to go add a margin top of minus 50 pixels. I'll refresh and watch what happens. Box 2 has effectively moved up by 50 pixels, and you'll note it's on top of box 1. And again, that's because box 2 appears after box 1 in the markup. Now, this is not common to do, adding negative pixel values, but this is a good way for me to demonstrate what happens when our elements are in the same plane and overlap. Now, I just want to highlight, I specifically haven't used positioning properties here to move our elements on top of each other, because it's kind of like those created other layers. What I wanted to demonstrate here was that by using negative values for margin, I'm able to move our elements on top of each other, but they're in the same plane. And when they're in the same plane, the stacking order just depends on the order they appear in the HTML. So let's now take a look at Z-index. The Z-index property controls the vertical stacking order of positioned elements. By positioned elements, I mean there that the element has a position property like relative or absolute. In CSS, the property looks like this: Z-index with a numerical value like 2. The number represents the stacking order. We can think of Z-index like stacking plates. We have our bottom plate representing an element which has a Z-index of 0. The plate above this would have a Z-index of 1, and the plate above this, or the element, would have a Z-index of 2. So when elements have a position property on them, you can add the Z-index value to control the stacking order. Looking at this in diagram form, we have our 2D plane, X and Y, and this plane by default has a Z-index of 0. So an element on this plane would have a default Z-index value of 0. On the right, I'm going to demonstrate what this all looks like on a web page. Initially, we just have our red element. Let's now go add a Z-axis. That is a third axis, creating a 3D space. Let's now go look at when an element has a Z-index of 1. We have an entirely new plane, and the element here would have a Z-index of 1. On the right, looking at our web page, the blue element would appear above the red element, because it has a higher Z-index value. Let's now go look at another plane, where the Z-index is 2. We have a green plane over here, an element with a Z-index of 2, and on our web page on the right, this would appear above both the blue and red elements, as it has the highest Z-index value. And I want to highlight again that Z-index only works on positioned elements. Let's go play around with this inside VS Code. Alright, so this is where we left off earlier, and we saw that when elements overlap, like when using a negative margin value, causing box 2 to overlap box 1, the stacking order was just determined by how they appear in the HTML. Because box 2 appears after box 1, it appears on top. Now, simply adding a position property onto an element actually doesn't change this. It's only when you explicitly add a Z-index value. Let me show you what I mean. I'm going to get rid of this margin top, and I'll refresh. Let's go position this element with the value relative. We know that this means that the element is now going to be positioned relative to itself, where the reference point is the top left corner. I'm going to go add a top value of 50 pixels. I'll refresh, and this moves our element 50 pixels away from the top of the reference point, that is, down 50 pixels. You'll see that it appears to overlap box 3. Now, from CSS's point of view, box 2 is not actually in its own layer. It's still all within the same plane. The reason it seems to appear on top of box 3 is because as soon as you add a position relative onto an element, the browser will always give priority to rendering that on top of non-positioned elements. If I go and change this to bottom 50 pixels, again, it will appear above element 1. Okay, I'm just going to change this back to top. And what I want to go do now is just add the position relative onto box 3. I'll refresh, and you'll see that because box 2 and box 3 are now both position elements, the reason box 3 appears on top of box 2 is just because in our underlying HTML, box 3 comes last. So I just wanted to show you, although it seems like adding a position value onto an element, that it appears on top of other elements, we are still in fact in the same plane. Okay, I'm just going to add position relative back onto box 3. And I want to show you now how Z-index works. At the moment, the default z-index value of any positioned element, like box 2 and box 3, is 0. Just to show you this, I'm going to add a z-index of 0, and over here a z-index of 0. I'll refresh and there is no change. Both of these elements are in the 0 plane, which you can just think of as the xy plane. But now watch what happens when I change the z-index of box 2. I'll change it to 1, and I'll refresh. What this is saying is that box 2 should now appear in its own layer in another plane. Think back to the diagram we looked at earlier. Box 2 is now essentially in the z plane of 1. So it now actually is in its own layer. I can change the z-index value here to 2, and that will now push box 3 into its own layer. So box 1 is in layer 0, box 2 is in layer 1, and box 3 is in layer 2. And whatever the highest z-index value is will always be on top. For example, I could give this a z-index of 99. And this is now in the z99 layer, way above the box 3 in the second layer. We can also use negative values. So for example, if I gave this a z-index of -1, you'll see this effectively disappears. And that's because it's gone behind our container, which is just in the default z-index of 0 layer, that is the xy plane. Box 2 is now behind this layer. All right, I'm just going to bring it back to layer 1. So just to recap, when your element is positioned, like box 2 and box 3, we can explicitly define a z-index value which moves that element into its own plane. And whichever element has the highest z-index will always appear on top. Okay, so now let's discuss the concept of stacking context. A positioned element with z-index creates a new stacking context, where its children are stacked independently of other elements. All right, that's a bit of a mouthful, so let's understand this in diagram form. I'm going to first split out our different planes. Focus now on the z-index 1 plane. I'm going to expand this element vertically. This element will now act as a container, and I'm going to give it a child element in black. Now the z-index of this child is only relevant within the parent. So for example, if I gave this child a much larger z-index compared to what else is here, like a z-index of 10, take a look on the right to see how this would appear on the web page. The black element doesn't actually appear above the orange element, even though it has a much higher z-index value. And that's because any child elements within a container that already has a z-index value, like the blue container, is only relevant to its parent. So each of our elements, the red z-index of 0, the blue z-index of 1, and the orange z-index of 2, each have their own stacking context, which means that any child elements which have z-index values are only compared to inside the parent element. It's kind of like the other elements in the other planes don't exist to the child element. So even though our black element, which has a z-index value of 10, is the highest z-index value across all the planes, the value 10 is only considered within its parent. So let's go check this out in VS Code. All right, so I'm back where we left off. I just want to move box 2 slightly up. So I'm going to change the top offset to 20 pixels and refresh. Let's now head to index.html. And I'm now going to go add a div with the text child1. And I'm going to give it a class of child-1. I'll copy this div, change this to child2, and give this a class of child2. I'll head to app.css. Let's go select child1. I'm going to give it a height of 50 pixels, a width of 150 pixels, and a background color of red. I'll copy this class, change this to child2, and give child2 a background color of yellow. All right, I'll refresh, and we can see child1 and child2 inside box 2. So what's happening here is that our box 2 has a z-index value of 1. Now, child1 and child2 are children of box 2. So inside box 2, it's like we're back to a z-index value of 0. And that is what we mean by stacking context. Box 2 is its own stacking context. So let's add position relative to child2. I'm then going to add the bottom offset property and give it a value of 20 pixels. This now moves child2 above child1. And we discussed earlier, this is occurring because any element in the same plane that has a position property will always appear above. I'm also just going to go add position relative onto child1. I'll refresh and there's no change. Because both of these are now positioned relative, child2 will still appear above as it appears last in the HTML. But if I now go add a z-index value of say 1 to child 1, you'll see it now appears above. Child 1 is now in the z-plane of 1 inside box 2. And like we saw earlier, if I come and add a huge z-index value, which is well above the z-index value for box 3, child 1 is only going to be the highest stacked element inside box 2. I'll refresh, and as you can see, child 1 is still above child 2. But watch what happens when I change the top value of box 2 to something like 120 pixels. I'll refresh, and you'll see that child 1 is going behind box 3. So even though it has the highest z-index value compared to box 3, which has a z-index value of 2, this z-index of 99 is only being considered within box 2, which is its stacking context. So just be mindful when applying z-index values to children elements that they could be within their own stacking context, being set by its parent. So let's wrap up by building our next summary card, z-index, stacking, and transform. In this chapter, we looked at z-index and stacking context. We saw that the z-index property controls the vertical stacking of positioned elements. We looked at this diagram where we had an element with z-index of 0, which is just the default value. And on our web page, it would appear like this. We then added a z-axis and added a new plane which contained an element with a z-index value of 1. On our web page, this would appear above the element with a z-index of 0. We added a third plane, which had an element with a z-index value of 2, and this element would appear above the blue and red element, where the highest z-index values are on top. Each of these elements, which had different z-index values, created new stacking contexts, where any children inside these stacking contexts that had a z-index value were only considered in relation to their parent. For example, if we expanded the element z-index of 1 to become a container, and we added a child element with a z-index value of 99, the z-index of the child is only relevant within the parent. So even though it has the largest z-index value in this setup, it would never appear above the orange element, because it's a child of the element with a z-index of 1. And the z-index of the child element is in a new stacking context defined by the parent z-index of 1. Alright, so I'm back inside our Quill project. Now, we just spent a lot of time on the theory behind z-index. And honestly, it's one of those things that's just more important to know about, and at this stage won't have too much use. But I am going to show you an example of where the concept of z-index would come up. On our Quill homepage, not too long ago, we created this chat icon, which is fixed to the bottom right of the viewport. Now I want you to imagine that when you land on the page, after say 10 seconds, a full screen modal window appears. A modal window is the same thing as a pop-up. So at the bottom of our HTML, we have our chat container, which is living outside the main container. I'm now going to go define in HTML a modal window. I'll create a new div. I'm going to give it the class modal. Let's add an h2 with New Year discount. I'll add a paragraph with get 50% off now. And let's add a button with the text claim now. All right, I'll refresh. And our modal window is just at the bottom left here. Let's head to app.css. In our components, I'm going to scroll down to just below chat icon, and let's go select the modal. I'm going to give it a position of fixed. I'm going to position it from the top of 0 and the left of 0. This effectively positions our modal in the top left. That is 0 away from the top of the viewport and 0 away from the left of the viewport. I'm then going to give it a width of 100% and a height of 100%. In our HTML, the modal's parent is just the body tag. So the modal's width and height will just be 100% of the body. So I'll refresh, and our modal is now taking up 100% of the page. Just to better see this, I'm going to add a background color of white. I'll refresh, and you can see the modal is taking up 100% of the page. Let's just vertically and horizontally center this. We'll add display flex. We want our main axis running from top to bottom. So we'll change flex direction to column, and to vertically and horizontally center, we'll set align items to center and justify content to center. I'll refresh, and our content now appears in the middle. Now this chat icon in the bottom right is appearing above our modal. So what's going on there? Because our modal has a position property of fixed, and our chat container also has a position property of fixed, our modal and chat container are both positioned elements. The chat icon appears above the modal because that's the order in the HTML. the chat icon comes after the modal. So one simple fix would just be changing the order. I could cut this and paste this before the modal. I'll refresh, and you'll now see the modal appears on top. Let me just put it back to where it was. I'll refresh, but a better practice is to instead add a Z index onto our modal with an extremely high value. So we know that no matter what the HTML is, the modal will always appear above everything else. So in app.css, let's grab Z index and give it a value like 999. I'll refresh, and you'll now see that our modal appears above all the other elements. And that's because it has an extremely large Z index value. So even though the modal in the HTML appears before the chat container, it has a very high Z index value and will always appear above everything else. Okay, this was just for demonstration purposes of where Z index may come into play, but I'm going to remove it from our Quill project as we won't need it moving forward. In the final chapter, we'll dive into applying rotations, scaling, and other visual effects to elements using transform. We'll be discussing the transform property, transformation functions, and positioned elements and translate. So what is transform? Transform applies visual transformations to an element like scaling, rotating, translating, and skewing. In CSS, it looks like this, where transform is the property name, with the value being a transformation function. In this case, it's a scale transform function. The different values can be scale, skew, rotate, and translate. So let's take a look at the transformation functions in more detail. The first one we have is scale. This resizes an element horizontally and vertically. It looks like this, where the first value in the parentheses is the x-axis scale factor, which is then comma separated by the second value, which is the y-axis scale factor. So in this case, our element will be scaled 2 times horizontally and 0.5 times vertically. The next function is skew. This distorts an element by slanting it horizontally and vertically. The function looks like this, where the first value is the x-axis slant angle, and the second value is the y-axis slant angle. So for this element, it's being skewed 20 degrees horizontally and 50 degrees vertically. The next function was rotate, and this rotates an element around its center. It looks like this, where the value in the parentheses is the angle the element's being rotated by. The last function was translate, which moves the element horizontally and vertically from its position. It looks like this, where the first value is the x-axis translation. In this case, a percentage value is used, and the second value is the y-axis translation. In this case, a negative pixel value is used. So let's go play around with these inside VS Code. Alright, so I've gone ahead and set up an index.html file and linked a style sheet which is currently empty. Inside our HTML, I'm going to add a simple div and give it a class of card. In our CSS file, I'm going to select the card. I'm going to give it a width of 200 pixels, a height of 200 pixels, and a background color of salmon. Okay, let's check it out in the browser. To better demonstrate this, I'm just going to move the element away from the edge of the browser. I'm going to give it a margin left of 100 pixels and a margin top of 100 pixels. I'll refresh, and this just moves our element slightly away from the edge of the browser. So let's now go add our transform property. I'll grab transform. The first transform function we looked at was scale. The first value is the amount to scale in the x direction. Let's make this 1.2. And the second value was the amount to scale in the y direction. Let's make this 1.5. Okay, I'll refresh, and you can see our element has scaled by 1.2 times horizontally and 1.5 times vertically. Now, this might seem a bit random. We could have just made the card this size. That is a width of 1.2 times 200 pixels, which would be 240 pixels, and a height of 1.5 times 200 pixels, which would be 300 pixels. But what we can do, which is quite cool, is select the card's hover state and add the transform property there. I'll refresh, and now when I hover over the card, you'll see it scales. And this is quite a cool dynamic effect. The next transform function we looked at was skew, where the first value was the x-axis slant angle. For now, I'm just going to make this 20 degrees, and the second value was the y-axis slant value, which for now I'm going to set as 0, just so we can see how it skews in the x direction. I'll refresh and hover over the card, and you can see it skews by 20 degrees horizontally. Let's go swap these around now. I'll put 0 there and 20 degrees here. I'll refresh, and you'll see now the element is skewing 20 degrees vertically. Let's make them both 20 degrees, and you'll see the element is scaling both 20 degrees horizontally and vertically. Okay, the next function was rotate, and this was a single value which rotated the element around its center. Let's make this 45 degrees. I'll refresh, and you'll see how the element rotates by 45 degrees around its center. The last function was translate. The first value was the amount to translate in the x direction, which I'll set as 100 pixels, and the second value was the amount to translate in the y direction, which I'll also set as 100 pixels. I'll refresh and hover over the element, and you can see it's moving to the right by 100 pixels and down by 100 pixels. So those are the default positive value directions. A positive x value, like 100 pixels, moves it to the right, and a positive y value of 100 pixels moves it down. If I now make these negative, so negative 100 pixels and negative 100 pixels, I'll refresh, and you'll now see the element moves the opposite direction, that is, to the left and up. Okay, I now want to spend some time talking about positioned elements and translate. One thing you may be thinking is, what is the difference between translation and using the position offset properties? Well, using positioning and translate together provides precise control over element placement. Let's look at an example of this in diagram form. Let's say we have a web page defined by the root HTML element. Inside the page, we have a purple container, which is a div. We can absolute position this div with the property position and value absolute. We know this removes the element from normal flow and allows us to use the offset properties. For an absolute positioned element, we know that the offset properties are in relation to the closest non-static parent element. And if there are none, it's just the root HTML element. So in this case, our reference point are the edges of the root HTML element. So if we applied position left, this would move our purple div 50% from the left edge of the HTML root element. That is 50% of the parent. I'm going to draw a dashed line to mark 50% the width of the HTML root element, and our purple div will move like this. If we then applied a top of 50%, our HTML element will move 50% of the parent. That is 50% vertically of the root HTML element. I'll draw a line on our root HTML element, dividing it in half vertically. So our purple div will move like this. So what we end up with is that the top left of the element is centered, using our offset properties when our element has a positioned value like absolute. Now, this doesn't actually help us if we wanted to get our element smack bam in the middle of our web page. The top left of the element is in the middle of the web page, but in a lot of cases, we would actually want the middle of our element to be in the middle of the page. So to achieve this, we also need to use the transform property with the translate function. And it would look like this. For the x value, we're using minus 50%, which will move the element 50% of itself to the left. So it moves like this. And for the second value, which is the y-axis, we're again using a negative value of 50%, so it moves 50% of itself upwards. So it ends up perfectly in the center of the web page. So this is a good demonstration of using offset properties with positioning and translate, and how you can use them together to achieve precise placement of elements on your web page. Let's go play around with this inside VS Code. All right, so I've gone ahead and set up an index.html file and linked a style sheet, which is currently empty. In index.html, I'm first going to add some paragraph tags and add a whole bunch of lorem ipsum text by typing lorem times 30. I'll then come down to the bottom, add a div, give it the class modal, as we're going to be making a modal window, that is a pop-up. Inside the modal, I'm going to give it an h2 with the heading modal window and some paragraph text modal paragraph. All right, in app.css, I'm first going to go clear out all the default margin and padding so we can work with a blank slate. I'll select the modal. Let's give it a width of 300 pixels, a height of 300 pixels, and a background color of light gray. All right, let's check this out in the browser so far. Okay, we can see all our lorem ipsum text, and if I scroll down, our modal window appears at the bottom here. So let's first go use position offset properties to start centering this modal window. On the modal, I'm going to go add the position property and give it a value of absolute. I'll refresh, and our modal window is now absolutely positioned. I'm going to move it left by 50%, the parent of the modal window is just the body tag. So it's going to move 50% the width of the body, and I'm going to move it from the top 50%. So the modal is going to move 50% from the top of the body tag. I'll refresh, and scrolling up, our modal is now 50% the width of the body tag and 50% the height of the body tag. But we want to get it into the center. So to do that, we use the transform property, grab the translate value, translate it negative 50% of itself, which will move it 50% to the left, and negative 50% of itself in the Y direction, which will move it 50% of itself up. I'll refresh, and you can now see the center of our modal window is perfectly in the center of the web page. Now if I scroll down, it doesn't scroll with me. But we can easily fix this by changing the position value to fixed. I'll refresh, and you can see the modal window now perfectly remains in the center of the web page even when I scroll. So you can see that for positioned elements, using offset properties, in addition to the transform translate value, enables us to have precise control of the placement of elements. Now, one question you may have at this point is why can't we just use Flexbox? Flexbox is a great way to center elements horizontally and vertically. Now, the reason Flexbox wouldn't be a good option here is because we want our modal window to appear above other content. By default, when setting a positioned value on an element, the browser will automatically render this above other content. Also, using a position value like fixed gives us access to the Z-index property. So I could add a Z-index value of say 999, and this would ensure that this modal window always appears above the other content. You just can't achieve this with Flexbox. The Z-index property only becomes accessible when you're using a positioned value. So for a case like this, where we want a modal window to always appear above other content, it's better practice to position it and use offset values, and then use the transform property and translate function to perfectly center it in the middle of the page. Now, of course, Flexbox is available to use inside the container. So for example, if we perfectly wanted to center this content, the heading and paragraph, which are children of the modal, we could add display flex. We would change the flex direction to column. We would apply align items center and justify content center. I'll refresh, and doing this is perfectly acceptable. We're centering the content inside the modal window. What we're not doing is using Flexbox to center the entire modal window on the page. We're using the offset values and the transform property. So let's now take a look at some transform guidance. Scale is often used when hovering over an image to create a dynamic visual effect. So this transform is being triggered by state change, which we played around with earlier in VS Code. Taking a look at an example, looking at the middle image, if you were to hover over this on the web page, its size scales up. So the image enlarges when hovered over, creating an interesting visual dynamic effect. Translate is used on position modals to achieve precise centering within their containers. Here's an example of exactly what we did in VS Code earlier. Here's a modal, which is centered on the web page. This is achieved by positioning the element with a fixed value, offsetting it 50% top and 50% left, and then using the translate function to center itself left and up. Translate is used on positioned alerts to achieve precise alignment in the top right corner. Taking a look at Etsy, which is an e-commerce site, I'm going to zoom in on the cart in the top right corner. We have a parent element, which we would give a position relative value to act as an anchor, so that our notification circle can be positioned absolute, so that we can offset the notification number in reference to the closest positioned ancestor. In this case, the shopping basket icon. On the number 1 notification, we would use our offset properties, like top 0 and right 0, to move the icon to the top right of the shopping basket icon, and then we could use the translate function to move it 50% to the right and 50% up, so that it would appear in the top right corner. So let's finish off our summary card, Z-index, stacking, and transform. In this video, we looked at transform functions. We saw there were 4 types. There was scale, which resizes an element in the X and Y direction, where the CSS value looks like this. We have skew, which slants X and Y, and the CSS function looks like this. We have rotates, which rotates an element around its center, and the transform function looks like this. And we have translate, which moves an element X and Y from itself, and the transform function looks like this, where you can use percentage or pixel values. We then spent some time discussing positioned elements and translate. where we saw we could have precise control of placing an element using both positioned offset properties and the translate function. We have our web page in grey and a red container element like a div. We would absolute position this element. Now, because the element is absolutely positioned and there are no other elements on the page, its reference point are the edges of the web page, that is, the root HTML element. So using offset properties, you could apply left of 50%, which would move our element 50% of the parent. So it would end up over here. We could then use the offset top and set it to 50%, which would move the element 50% of the parent's height. So it would end up over here. And then to perfectly center the element, we would use the transform property with the translate function and set the x value to minus 50%. So it would move to the left 50% of itself and end up like this. And the y value is set at minus 50%. So again, it will move 50% of itself in the upwards direction. So it would end up like this. So our element is perfectly centered on our web page, using both positioned offset as well as the translate function. Alright, as I've mentioned already, I'm actually happy with where the Quill project currently is. However, I do want to demonstrate the transform property on our homepage. So the first thing I'm going to do is I'm going to go add a little beta symbol in the top right corner of the Quill logo to signify that this application is in beta. The second thing I want to do is very slightly scale our buttons when we hover over them, just to give a bit of a visual dynamic effect. So let's go handle the buttons first. Alright, so I'm back inside our app.css file of the Quill homepage. I'm going to scroll down to our button